at Tibet House. We are very grateful to all our speakers for accepting our invitation and being a part of this panel. And I also would like to thank all the participants here for joining today's program, today's first session. So for this session, we have a very interesting topic, that is quantum evolution of the principle of causality from antiquity to its relevance to quantum physics versus true truths, with emphasis on emptiness as the foundation of all existence. And for this session, the chairperson is Professor C.C. Royla, and the speakers for our first session are Venerable Geshe Tenzin Selekla. I would like to bring to your kind notice that Dr. Srikant Radhakrishna ji had some personal issues, so he wasn't able to come for the conference. Instead, I would like to request Professor C.C. Royla to please speak on his behalf. Since our program coordinator Domala has already introduced Professor C.C. Royla, so I don't think another introduction will be needed. So we will directly start with the session. So I now request, along with all the speakers, to please come on stage. Thank you.
Excuse me. Oh, you have the introduction. Okay. The first session, and we have three speakers, because the fourth one, Dr. Srikant Radhakrishnan, he could not come here because of his health issue, and maybe I would speak on that issue at the end, because I have not prepared the full-fledged lecture, but I know the subject and I have a published book on that issue. So I will say something by last one is equivalent to PhD in Buddhist philosophy from two highly esteemed Tibetan Buddhist monastic colleges, Drepung Losang Ling College and Institute of Buddhist Dialectics. Currently, he is serving as a Buddhist philosophy lecturer at the College for Higher Tibetan Sea Learning Facilitator, international colleges and institutions.
I bow to you, O Conqueror, you who saw Tibetan origination and taught it. Respected guests of honors, Sangha communities, and esteemed speakers, and all the participants. And thank you, Dr. C.C. Roy, for a kind introduction by the Tibet House. And this is my first, quite nervous. And on top of this, the topic that was given to me was, I would say it's a profound, a very complicated and emotion right now, but hopefully bear with me please for 20 minutes. Also, I've laid down the outlines in four major outlines: the ontological reality, excluded middle, and application of logic, excluded middle on Buddhist perspective. So these are the four outlines that I have drawn, and I have to make the relationship between the actual topic and my specific topic to draw these lines in between. So on the beginning, difference like the similarities and the role of the logic, and then within the logic and reasoning, my specific topic, the logic of excluded middle. What are the importance of this and significant role of the ontological reality or the objective reality? I think like these topics, that first of religion aspect of what is the reality. So my happiness here doesn't mean, and more mean from the different, we say reality, and all is the happiness. I like nowadays happiness is equal suffering. So a kind of sensation do you experience is a happy because like different like a neutral sensation, but this is like the state that we are free from the COVID, and it's a happy state. So happiness doesn't mean that always a pleasurable sensation. Oh, without taking much time. So in Buddhism, like, so all the sufferings that in Buddhism, Buddha tried to identify what is this root of ignorance is, he said, like, he clinging to the notion of like a wrong notion of self, not just ignorance doesn't go, in order to dispel that wrong view, the right vision, or the excluded, now, the logic, the role of logic and the reality. Now, in order to like see the reality, in order to realize, so we use different kind of logics and logic of excluded middles means direct opposite to each other. So this topic was very like, since like being a monk and geshe and study to be a debate hack, but we every day like 5 hours, 6 hours a day we spent debate in the courtyard on the important concept of Buddhism's like Four Noble Truths, how the two truths are like labels, shunyata, all these things we debate, but never have much like chance to examine what kind of logic that we are using itself become the self was correct things. So it seems for me that the logic, since actually the logic is a tool to see the reality, but if you again testify that I can use the metaphor of the Madhyamika that you are mouse and asking me where is the horse to prove or establish. Now let's do. Thanks for choosing this object. Thanks for giving this like topic, and let me remind how this logic runs. Thank you. So one of the great, the Master Kamalashila, in his like in this clearly I quote, to negative determination to conceive or something is mutually the opposite one or the other one should established to your mind. So this is the logic. So I'm going to give example down, sorry. When we call the one of them and the other and independent, these when we take a phenomena, let's say when it rejects the concept of non-matter. When someone able to posit that human is not a matter, indirectly or directly, if things is empty of independent, then one should be dependent. No need to say dependent, but it's saying it already prove or establish or claim that the self is independent because it is empty of dependent. So from the Buddhist point of view, we say that everything is interdependent. You cannot, it's work useful to establish one's view. So in Buddhism, when we say, like, not just Buddhism, when we argue or when we posit, or when we like debate, in the debate there are three touching others key. Then at the end, debate, and when we posit one's own view, we use this logic on daily life. So, not all contradictories are mutually exclusive contradictory. This is important. Like example, yellow and blue color. So this yellow and blue is contradictory, no doubt. Yellow each other, right? There is a third possibilities. Neither of these, right? So these, they shouldn't be any. You have to say everything is independent, or you have to say everything is dependent. But there is no third, like a middle. In this point of everything is like shunyata, the very like, it's coming next, the idea of shunyata. On this, the logic of excluded middle, we prove that everything is, with like the external, like, I don't know, just like the external phenomena, if there is like too hot inside, the only thing is, even though it's because, but the only thing is to opposite force or bring the countermeasure, which is the hot. If you raise the hotness, if you raise the temperature, then only thing is the only time that you can eliminate in darkness. External phenomena using the opposite will encounter, like we will cause a like sense of compassion and then like eradicate all those hatred and thought of hatred. So this is kind of system is being used here. So now, okay, yeah, I will finish. The logic of shunyata, the view on shunyata that Lama Tsongkhapas like to say, if there is no self, let's say there is no self, selflessness, the concept of selflessness. So without understanding what is self, the object of negation, without understanding what is the self, without understanding like, who knows Tashi, who is Tashi, or then ascertain in your mind. So the famous analogy, you all know, I've gone through, I just write a rope, snake, and famous analogy used by the, so when you see a rope, seeing a rope, then the fear comes, right? Let's say all of us are feeling emotion here. Now, see, right? No outside, definitely outside won't help. Having compassion will definitely going to reduce, so it won't help. There's no snake in the room, but it's like still something there, even the snake and other, right? So the best thing, the only things to free the fear of snake is like bring this person in this room, lit the light, and then see the rope as a rope, and seeing the rope is not a snake, right? The fear is the only way to. So I think, seeing the Metta, not seeing the cats by not. You should say.
Issues, and it would be really, we fixed it, but he didn't exclude it. Law. Not only yes or no, the people are trying to build a logic like computer. We say, well, this, and professor in the department, his in terms of quantum mechanics, philosophy of science, time period is 20 minutes. Okay.
Which one is it?
Or Ramanathan.
Where is it? Do you want me to write here? When is it? Second one.
Namaste to very causality, the tolerance in quantum physics, perspective. Great dialogues have been epistemology. Dialogues, in fact, he didn't write many years of his dialogues. Timaeus and also the teacher of Alexander the Great, he made a more elaborate extension of the idea of causality. And cause in Greek is called aithai, and he says any object, say a marble statue, is recognized only in relation to aithai, with which makes it different from every other object. What he called the final category, and called it the formal cause. So this categorizations, philosophers from 10th century BC onwards, because the antiquity of Indian philosophy is not known. It may be much older, because there was no mention of dates in our ancient literature. So in the ancient Indian philosophical context, the question of causality is treated as a dual of cause and effect. So the divergence of different schools, as Professor Sampton also pointed out, there were 6: Vedshika, Vedanta, Nyaya, and Mimamsa. So the 6 branches of Indian philosophy, which all of whom accepted the sanctity of the Vedas, but the Shravana schools, sanctity. But among these schools, there are 2 distinct ideas of causality. One is to take cause and effect as a compound dual, a single entity, where the cause and effect just change their roles. The effect becomes a cause, and then the cause becomes an effect, and so on. And these, the Vedantic schools call this the Satkaryavada, and the Nyaya, Mimamsa, and Buddhists, they disjoint, though they are joined in the sense that causes the effect. So the cause, that is, they are not the true Karyavadas. So anyway, so that was the one example of the cause-effect discussion. Whether the thread itself has the 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 thread contains the thread, there is no cloth. But whether the thread itself has the cloth in its existence. Then the discussions continue about the infinite and the cause of the weaver and so on. The Christian theologist Thomas Aquinas was one of the founding theologians of Christian philosophy. He was basically tried to make the Christian notions in the 13th century. He took this cause-effect chain to the final cause, resting in the Christian conception of God. So that was the discussion in antiquity. The principle of pratitya samutpada originating from another. It's a very basic thing. Like if somebody hits you, there is pain. So the cause of the pain is in the hitting. But if you go on analyzing this, the cause becomes the effect of something prior to that. And again, the chain goes on and on. So this was the problem of philosophy that even the ancients were aware of. But when the modern age physics dawned in after the Renaissance in Europe, the greats of the philosophy of science, namely, defined the causality principle as a mechanistic thing. That is, they defined the law of causality in mechanistic terms by positing that the motion of particles which are governed by laws of motion are causal in the sense that they determine the development of the motion from the initial time and space position to a final time and space position. The action of the causal force results in the specific path, that is the effect for the trajectory of the particle. So the mechanistic view of causality is that there is an initial state, the action of the force, and then the development of the state of the particle to a final state, which is the effect. So this is a mechanistic interpretation of causality, where an external force, the idea of an external force, it determines, it gives rise to a causal development. So all the laws of science and physics are causal laws. They take you in time from one initial state to another final state. So this is the causal development of a mechanistic system. So the cause was identified with the moment the external force acted on a particle or an assembly of particles, and the time development of the system followed the causal physical laws. Therefore, in a way, cause-effect relation is a time-dependent relationship with the sequence in time is in relation to the chronology. As time goes forward, the cause and the effect, they follow the trajectory of the time development. So from initial state to final state, there is a causal connection. And the causal connection is made by the causal laws of physics and science. So that was the idea. So the arrow of time is basic to causal development. So the past and the future are necessary to chronologically order the order of cause and effect. So without this time arrow, we cannot determine which is cause and which is effect. And that is the problem as we go forward. I'll show you what the modern ideas of science, especially the relativity theory and quantum mechanics, what changes are brought into this idea of cause and effect. In fact, in the late 19th century, one of the greats of statistical mechanics, one of the originators of the discipline of statistical mechanics, Ludwig Boltzmann, pointed out that the arrow of time exists for us humans because we are all entropic entities. Entropic in the sense we are all thermodynamic entities. We draw our energy from the environment and maintain the order of this bodily system for a short period of time. So you cannot go from an old man to a child. You always progress from a child to an old man or an old lady. So there is this arrow of time. And this arrow of time is because of the entropicity of our existence. We exist in a thermodynamic world where our entropies always go from order to disorder. So this sets the arrow of time. So that is why we are also talking of causality. But the whole thing changes drastically when you go to the modern theories of relativity and quantum mechanics. The advent of relativity and quantum mechanics in early 20th century made the causality principle stand on its head. In relativity, past and future become relative, and so does the sequence of cause and effect. The imposition of speed of transmitting information requires a definition of causality between two space-time points separated by distances which are of two kinds, namely the two positions A and B which can be connected by a light signal. And the two, when they are not connectable by a light signal because of the limitation in the, because Einstein said that the velocity of light is the upper limit for all velocities. No physical material object can reach the velocity of light. Velocity of light is the upper bound. Beyond that, you cannot have a physical system which moves faster than light. So light sets the velocity of light sets the barrier, upper bound for information to be passed from one point to another. So if 2 points are connectable by a light signal, then the 2 points are said to be the relativistic redefinition of causality. So what in technical parlance is called space-like separations are acausal, and time-like separations of points is causal. So that's a cause and effect relative nature of the quantum, which can only be described by a wave function, which is governed by the superposition principle, makes the time ordering of cause and effect impossible. For example, a mango inside a sealed box may either be fresh or rotten. Of course, this is just a restatement of the famous Schrodinger cat, but I replace the poor cat with a mango. So the mango can be either in the rotten or fresh state. So whether it is fresh or rotten, even in classical cases, only by opening the box you can, and inspecting the state of the mango, you can say whether it is fresh or rotten. But in quantum mango, superposition says that the psi mango is a superposition of these two states, fresh mango and rotten mango. And in this expression, A and B are numbers which determine the magnitude of the probability with which the mango could be found either in the fresh state or the rotten state. So the causality principle just in the case of quantum procedure, your experimental setup, Costa et al. Are subjected, they come in two paths. The sequence is like, in one the sequence is and by a similar supercurrent wave functions. So when you make causality, it's a very important experiment, as tells us that quantum mechanics does not respect even the relativistic, right? Because the of time is independent of the causality. This is the one. I'm a person.
Philosophy. With one of his disciples, water in the river, not only discontinuous, but it was a speculation, which there is no causation for every direction. So that my friends in that direction then went to lower Tibet, Bachelor of Dialectic, all of practices at Oriental Institute study.
Dr. Sumit K. Mishraji. It's a fortunate and also it's a great honor and also it's a privilege to in the Institute of Buddhist Dialectic realize the ultimate truth. Regarding the Buddhist the speakers in the afternoon who will talk about the character, eternal wisdom and the ultimate truth. So as for the four seals of the Dharma, all composite phenomena are impermanent and all contaminate through peace. So I will discuss the existing person, but includes all others. In the conventional truth, the truth will not be attained. So when we talk about the emptiness, or the emptiness or the ultimate truth, we know the truth and the emptiness or the ultimate truth, it's a kind of like two phases of what he said was, without identifying what to negate, one won't understand the ultimate. So to understand the emptiness or the ultimate truth, it's important, dependent origination. What he said was, if a person who doesn't see the tree, I will answer, yes. Ask me, oh, do you see the tree? I will answer, to whom to talk to. By the Buddhas rely, we see the thing, me in the first, we attach to it, we feel happy. And if we feel a little bit uneasiness or like dislike, then we feel anger or the frustration. People, they don't want to take it. Sometimes, the one time when I listened to the Jagjit Singh song, the ghazal, Jagjit Singh was saying, what is that? Yes. Now these days, doctors are, when we see the apple, like it's the independent existence, from where it's coming from. If we just try to introspect, without introspection, we see as it is. Right. Now with introspection, oh, the mic, who made it? Is it Ahuja or like something else? Oh, Ahuja. Yeah, this company is there. Oh, the metals, where does it coming from? Oh, the light. So, Vasubandhus. And as for the, not only with judging others, how did we destroying it? Right. We talks about empty. One day it will become other realms, and also the earth that we are existing right now will also really, one day it will come. When I address the nature of God without realizing the emptiness, it's very, very difficult to attain enlightenment. The bodhicitta plane won't be nature, the ultimate truth. Then the Arya Nagarjuna's precious garland, if the person is not earth, not water, not fire, not wind, not space, not also consciousness, and not all, and just think, whoever. Then with the consciousness itself, states are the basis for the attachment to both. Now, what is emptiness? Emptiness. I won't repeat it like zero. Thing walks out. There's the emptiness. What we think is, oh, it's very easy. But there are 16 different types of emptiness, 18 different types of emptiness. And there's one emptiness. The lower schools and the high. True plane to be, and with the dependent origination, go too much with it. Then 3 different types of dependent origination, all in parts, dependent origination. Things exist, some relation. Now here it says not at all. Only that should be affirmed by kind of convention first. Second, but also the reference of that convention should not be contradicted for ultimate mode of dispel the extreme. Also come to know how emptiness arises as extremes. Again, we have to die again. So, because of the ignorance, we have to develop anger, and also we have to develop the apparent, the real impermanence could. And what I will think is, oh, this is impermanence. Okay, let it be. Then right after a minute, I will see the glue. Oh, I will fix it. Understand. Appear to you as I to see to attain enlightenment. So that's the thorough modes of misapprehension. Now, in brief, so let's say all phenomena, including the self, lack intrinsic existence. However, because of our fundamental intimacy, so with that we say, oh, I know that I've understood it, right? Then later, Buddhism is the emptiness. Then we will see the ultimate truth as it is only the first bhumi. Then, after seeing the, let's say, the first bhumi, then you attain kind of like the things that we see now, and once we are different, but it helps you to understand. And in the movie, is asking to that boy, right? First, I just got wondered, what he said, Arjuna's view in one sentence. That too with a small boy. Thank you.
Thank you, Geshe Tenjin, for elaboration on concept of emptiness. We are almost at she used free will. One is quantum cognition. What is quantum? This is very, very. I will give the person before going to or decision making and the experimental cognitions. The whole empirical evidence, in effect. Second one, conjunction and disjunction fallacy cognition over distribution will take lot of time. So, university, maybe Italian university student from X, C, always prefer this man, always prefer probability theory. Go directly to the, you take a coin, 8 students under the call, win rupees. Now, this is the real lot of money, 200 into 59% they lost. Second performance, toss the coin and in it thought. Now, whether they have experimental results say they also took part in the second stage, and according to in a kind of one end of the spectrum own, other end of the spectrum lost, but someone is a mind of both win and if you if I will, so don't know what happened. This was done by undergraduate. Both are more prone to play for gambling rather than boys. We have not published the result, but it is under department experiment, and I am not going to tell you. Maybe let me go to. It's not possible to. It is called quantum-like cognition. But the problem is, what is when is between, say, quantum-like cognition and free will? There are two aspects. When you say that quantum-like cognition in the human brain, in quantum no two mutual, what is meant by infinite precision means will go to zero. Make the error variable in a both the indeterminacy, a free will. And other people, they initially speculated that this might give us clue to understand, because the brain very, very small scale, and nobody knows really how indeterminacy principle is effective in case of brain, because brain is macroscopic object, macroscopic domain systems or living organisms. We predict where discovered in my hand, if I change something which happens, deterministic, we will apply this kind of things for brain function, because you have to use nonlinear. The thing is that the Rejection probability theory. So you cannot say whether we don't know, we are ignorant of the initial condition, ignorance of knowledge. So up till now, this is the current status of the debate. In a philosophy, so debate, its basic. Susan has nothing to do with the mental process, like the mathematics and physics, because so logic is generally considered as a philosophy of valid reasoning. It is primarily studied in the discipline like philosophy, mathematics, semantics, and computer science. And I told you already that George Boole, English mathematician, developed a system of logical thought known as Boolean logic. And, or, and not are the common Boolean operations used in logic. But as soon as the different experiments, especially in microscopic domain, quantum theory comes, then it is shown it is non-Boolean logic. Some empirical, and many Buddhists may shed some new lights on this issue, that what is the role of logic and psychology, and then let me was supposed to give.
So now we'll start. So related.
Honorable Geshe Tenzin Self, you just mentioned in the end of your talk, seeing the non-existence and not seeing the existence, and is love and hate are
the self and the selflessness, and these two are, as I said, mutually exclusive to each other, right? So like independent and dependent, and like matter and non-matter, these are mutually exclusive, contradictory, and also the direct opposite. But so as I said, like these are the, like in these concepts, what we can apply is there is no third possibilities. Either the things should be, either apply these things like and like how the mutually exclusive, contradictory, because there are many emotions, neither love nor hatred. But we apply these like principles that in order to generate love, we like diminish the anger, and in order to like in order to release, like in order to measure, we use this logic as a base to bring the encounter force antidote, and then release the reduce the opposite. Thing is, you have to make distinguish between not seeing and seeing non-existence. So I'm saying that not seeing is the reason for seeing non-existence. Means that have to be. I asked like whether some of you might have like a is there any like spirit in this room or not? I would say no. I'm not going to say the non-existence of ghost or spirit in this room, because it means you have to reject the existence of God. Like without understanding the existence of God, without knowing the spirit exists or not, you can the empty of self. Like you have to identify the Sanlek. Without knowing Tenzin Sanlek, you cannot. If this room, in this room, by knowing, do we really? Hopefully you get it. You can easily say that there is no Tenzin Sanlek. Do we really need to know Tenzin Sanlek precisely to say there is no Tenzin Sanlek in this room? So I don't know how the logic prevails. If there is no general, if you like negate the general, I think specific. Yes, please.
His question is referring to own existence. I think he is referring to our own mental stream. One is to exist simultaneously in one's own, mental continuum at a time.
At the same time.
Right.
I don't think like.
Excuse me. Can I? Right. Let's say if you have lots of anger, then what we say is like do the permanent, or do the meditation.
Question is again to Venerable Geshe Tselep. If you'd one, and then we establish the ability, the concept of probability. It's a road accident, for example, either this or either that. What in this?
So the principle of two, for like the mango in the box, or you are in the middle. It's just you are like it's a different state. This because it's very much. I have to say there is provision. If things exist, like Buddha said, all phenomena are impermanent. So this is a provision. So to say everything, all cannot, without understanding the proper understanding of impermanent, to be make this doubt, you are not in this system of this principle.
Yeah, maybe I can add something more, because it's related to, like 19th century, he discovered a phenomena called placed in the water motion, paper, and he derived the theory. So here, this Brownian motion, this randomness is inherent or intrinsic in the coin. Mass of the determine what is. But the issue is, I know Jain philosophy, they specifically consider or use a term which is called related to probability. So whether in Buddhist philosophy you have that type of concept also, and what type of probability it might happen.
His Holiness the Dalai Lama, and the Buddhist religion, and the abilities, right, and the probability to finalize. So over here.
Or using that, why in Buddhism, it determines that.
A coin.
Yes. Once you have lost it, then it is
empirical phenomena.
Yeah. The flip code.
I am taking a coin. Outcome is once it will be here.
There is probability. Usual exclusive.
Modeling with explanation for probability.
Not take questions anymore. I would like to thank our chairperson, Professor Sisi Roila, for sharing this session, and I also would like to thank all our speakers for a very informative, and I'm certain that everyone has learned quite a lot on this session. So last but not the least, I would like to request Venerable Geshe Ngawa Samdila, close to all the speakers. Ramanathan ji, Itinze Thamjula, Geshe Ngawa Samdila. We will now disperse for a lunch break for an hour. I would like to request everyone to be back in the auditorium at 2 p.m. for our
of the day. Prasangika and concept of emptiness versus from Buddhist perspective. Venerable Geshe, following guest speaker from National Institute of Studies, Namgyal Institute of Tibetology, Dr. Nilsa Wangmula. Request Venerable Geshe Samdila to kindly come to the dais and occupy his honorable seat. Please welcome Gishla. And I would also like to Velji to kindly take the respective announcement. Dr.
Some second technical session and origination. The Vijnanavada and emptiness progressive school, they reject which is honor of the. It is interested to be not when in profuse which are regarded the phenomena. Exterior world, but as something. So the Madhyamika, and the other is from the objective side. At the same time, they are designated from the subjective side. So everything are merely designated concretely. So the ultimate level, at the highest level. Now in Prasangika Madhyamika, the three levels of Karan Bhava, as we have been listening since this morning, it is applicable not of all the results are dependent on causes. But when you reach at the Prasangika level, even the hetu doesn't become father or mother. The causes, unlike the earlier schools, they propose. Now, when we reach to the level, and very profound, that nothing can be established without taking into the whole the existence of the parts. And when we come to the level of designation and simply things existing only at the based on our mental and linguistic imposition and mental approach and conceptual approach. Three different levels of dependent and even the Vijnanavadas, from their perspective, the tenability of the system of the things doesn't work, right? So that is why in Mula Madhyamika Karika they have said that Master Nagarjuna has stated that how they argue against the Madhyamikas, that if everything is empty, then nothing can work, nothing can function. Even the three jewels and four noble truths won't work. But Master Nagarjuna and the following Madhyamika masters saying that if these subsequent in Master Nagarjuna yes shunyata yasya yujyate sarvam na yujyate tasya shunyam yasya na yujyate. For whom to whom emptiness. Sorry, just a moment, please. My glasses. For whom to whom nothing makes sense. So this is the ultimate kind of perspective of Prasangika Madhyamika. So with these notes, I would like to invite the speakers of this session. First of all, I would like to introduce Professor Satish Ji, Professor University of Massachusetts Amherst, USA. He is a founder director of the DEPA Solution Private Limited.
and mentor at he works with customers on solving real life problems using fundamental physics and data science. Sadishi also University. He has served as the chair of Computer Society of India, Bangalore chapter. His experience and IBM in many domains. Technologies and application of MI. Your presentation. Thank you.
I sent a PDF. Yes. And try to fit it in. Yeah. Namaste to everyone. So many distinguished people on the dais who are deep into philosophy, and while my philosophical seekings are only questions and no answers, my background is more of a practical. To do that, I haven't written in the presentation. To at least talk a few minutes about what I think is reality. Reality actually depends on the perceivers through the centuries of civil. It is telling us. In the beginning, we had access to only our senses, and our interaction asking those questions as to how does day and night happen. All these are questions that are relevant to our experience, our ability to see things. New ways of looking at the universe or extending our senses. For example, the telescope allowed us to see beyond what we could see before. So our reality got exposed beyond what we were able to see when we were only depending on our senses, and that continues to date. And this has led us to believe, for instance, the way we have been doing things, if we want to look at, our instinct has been and continues to be, it is constructed. Everything is thinking about explaining or understanding our universe. And that, for example, led us to start to understand how particles that today we largely believe will be the final constituents of matter in the universe. And also the way they interact are things that have been more or less discovered. Now, here is a big problem. While we believe that everything small that we know will constitute the universe, is it really true? For example, wetness for water together. It is most of everything on, and what I am going to talk about, and the way we don't know it is the universe that we believe we understand, or we are arrogant enough to believe we understand. Here is a rather intriguing poem by Keats. The way we work, there is, he was talking about a Grecian urn, and he said not only do these urns, not only do we understand things by our sensual ears, but also this is beyond what we could actually see. We are able to see things that we were not able to earlier see, and thus we need to be talking more. These are the things that let us understand. Really, what is a theory? A theory is a framework that helps you understand what you're seeing. If I see something and I want to understand how it came to be, etc. I was saying it's a thought experiment. It's a thought, it's a creative process that we try to understand from what we know before how this came to be. That is what a theory is. A theory of everything obviously is a theory that explains everything we know. And I want to emphasize the word we know, because we are not going to be even able to ask sensible questions about things we don't know. And like I mentioned about the dark matter, for example, or the dark energy, we know nothing about them except that they are there. That much is, like he said, we are absolutely sure that it exists. But it has the power. Through examples, attribute of a theory of everything should be, it should be simple, it should be beautiful. Whatever concept one has about what beauty is, but to be beautiful and elegant. These are the planets moving around the sun, everything were related. Newton phenomenon of other planets moving around the sun. So this versus huge objects like the Earth, other planets, and because we could, in the 19th century, they were familiar with the phenomenon of electricity and magnetism as two different entities, different kind of things. But Maxwell came along and said that actually the two are the same. He unified what seemed to be diverse, pole and a south pole repels another south pole and attracts a north pole and so on. And electric charges are charges that don't have two poles like that. But forces called magnetic force. This thought process, ethos, all through these centuries. If you come to the beginning of 20th century, there was relativity, that was quantum mechanics, shook the very way we thought about how things behave. And relativity questioned our understanding of the space and the concept of space and time. An absolute time, that anywhere anything has one quantity called time. And Einstein changed all that and said, no, time is relative. Time is used to physics. And it became obvious that towards the limit that if you did not partial reality. So Dirac combined relativity. So an electron would have an antiparticle called positron. And nobody had seen such a particle then. And a few years, perhaps a decade later, such a particle was indeed discovered. So diverse phenomena into one, it was into the reality, whatever it is, he was able to say that there has to be a particle called an antiparticle, and for the electron it happens to be a positron. Every time you see a phenomenon, if you don't want to have to test the ideal state. Existence of antiparticle, triumph of modern thinking of physics in the 1960s discovered. This approach of smashing particles to find out what they're made of led to a huge number of particles. These hundreds of particles that were being seen had to be brought under control, because there wasn't one consistent, simple, elegant theory that would explain all of that. So, looking at this in the 20th century, while that was happening, it was also discovered that nature doesn't have, we're all set, got another jolt. It turned out that there were more forces. And having one or two forces, we went now to it to try and understand these forces from one single framework. And this has been a remarkable success. But mind you, this is a remarkable to understand, and what we've been able to see, that's the 5% of the universe that we actually see. And many much smarter than, they have failed to unify gravity and these other forces. The other four forces, the so-called electromagnetic, weak and strong forces, have been unified. There is a beautiful theory that not only has being the Higgs predicted in 2014, in 2014 Higgs got a Nobel Prize for the discovery of the particle in CERN. Gravity, which explains the universe at large, that is, all the galaxies, the clusters of galaxies, the stars, their motion, etc., are explained by physics is to explain the micro world. Multiple of these coming together, which remains still an area that we are hazy about. So, in conclusion, I would say that we are not there yet. We don't, let alone in reality, that can understand this nature. Thank you very much.
Invite Professor Nirza Varma to speak.
Good afternoon, everybody. Maybe many of us are sleeping, or we have taken good lunch. Of the entities in the microscopic world. Here, my presentation will more present you some of the challenging issues which we don't understand. Maybe the eminent Buddhist scholars here, they can enlighten us. So, I will mainly focus on the issues we are facing in understanding image. And many people think that as soon as we go from bigger object to smaller and smaller object, called top-down approach, then entities like electron, protons, like other particles, and they are something else. They say sometimes a picture where you take the photograph, like so, or trajectory of the different. Similarly, in Higgs boson, Large Hadron Collider in CERN, they also detected particle like Higgs boson from this kind of experimentation. So, these are not like fictitious, somebody say particle or energy, no. These are real entities. Now, if you ask me, what are there is another attribute called spin, charge, or some other quantum numbers or some other attributes. They have written. So, we have an understanding what we call intrinsic property, and the philosophers and show the intrinsic property in quantum theory. What we in any standard textbook we say whether they are really intrinsic according to Buddhist philosophy or they are different. Say for example, in case of electron is a charged particle. It has a definite, they obey particular type of statistics. I mean, if you look at the distribution of the electron, then you can determine their particular distribution of electron called electron is a type or category of particle which is called Fermi-Dirac particle, which has different spin. They obey certain or like volume around center called nucleus of an atom. Like around the sun we have planetary systems. So, on the basis of that and outside in the different orbits electrons are moving. There you can define orbital angular momentum. So, they are called extrinsic property. One is Planck constant, it has a definite value. Another is gravitational constant and another is speed of say Planck constant, different. Wherever you measure, you get the similar to speed of light, 3 into 10 to the power 10 centimeter per second. This value, whether you measure here or in Bangalore. Now, the issue is that what we call intrinsic property, like charge, mass, or spin, whether they can be changed or it is their intrinsic attributes. Professor Satish was telling Dirac discovery positron. Positron has opposite charge of electron. It has the same spin, but it has same mass. Now, if one electron and positron collide each other, it will give rise to, if you start with the energy gamma, photon quanta, you will get electron and positron. So, the same electron, the fundamental, so these values, wherever you measure in the universe, you will get the same value. But there is a little twist in this picture. If you accept that quantum theory, that you can get a probability distribution of speed of light, C can take many values or H can take many values. Maybe for this universe, we have a fixed value of speed of the constant or fixed value of Planck constant. But in that case, we have to consider that there exist multiverse, different universes. I don't know numerical value, which is very difficult to understand within. And as I said, that intrinsic property and quantum physics. In quantum physics, basically, there are two categories of the entities or particles. One is fermion, another is bosons. Fermions, they have particular type of spin angular into bosons. I mean, you cannot change the value of the spin of the electron, say it is half, but you cannot change it to 3 by 2 or something else. So in the same electron, you will get always in the universe the same spin value or same mass value, I mean numerical value, or same charge. Directly to the idea of emptiness in Buddhism, which does not mean nothingness. I mean, this is the absence of inherent existence. But here, in quantum physics, we have the entities which have intrinsic properties or inherent existence. So, I don't know how to reconcile with the concept of intrinsic property in quantum theory as well as in Buddhism. That the famous text Mula Madhyamika, Nagarjuna's philosophy consists predominantly of reality, does not consist of independent substantial components, that is absence of svabhava, and which we have in quantum. Quantum speaker is there who is going to speak on quantum entanglement and non-locality. Some experiments, initially Einstein, Podolsky and Rosen, they proposed a Gedanken experiment, thought experiment, by which they said that after the first experimental test was done in Switzerland under Geneva Lake by Nicolas Gichon and his collaborators, that even if they separated two particles apart around 16 kilometers or 12 kilometers, I can remember, even it seems this correlation, say 10, you are separating the two electrons far apart. It is related or it is analogous to concept of interdependence. But the issue is much deeper. Here there is no correlation exists between electrons and proton or electrons and photons. That kind of correlation is not. Then when you make a statement, the concept of interdependence is there also in the physical universe. I mean, not I am saying in Buddhist philosophy, I am saying in physics, because there is a school of thought called Itacha interpretation by David Marmin and his collaborator. They say that this kind of correlations or non-locality exist all over the universe. But we are saying, first thing, to study this, then you can see only kind of correlation. Not only that, that correlation exists among not context of Buddhist philosophy like that. And the relational property. So intrinsic also, intrinsic relation. There is intrinsic relation and extrinsic relation. I don't know much about that. Maybe Buddhist scholars can elaborate, separated, and it seems they are correlated, called non. And now, relatum, the single, and the relation and relata, they are called, it constitutes a relation, and or examination relation is not real. But in case of quantum theory, the entanglement has proven to exist through laboratory experiments. So I don't know, many Hindu scholars, they also had a great debate with Dharmakirti's work, even in Jain philosopher, Prabhachandra and others. So we need to study how far this kind of philosophy of relation will be compatible with our present understanding of quantum non-locality or non-local correlations. Yeah. As I said, the Dharmakirti and his famous book, Sambandha Pariksha, but there is a great debate, and people in the West, they are perspective, but we should see Buddhist philosophers. So I can say that we can think of a possible dialogue. In Buddhist philosophy, there is concept of emptiness. Emptiness means that absence of svabhava or absence of intrinsic property. But in our case, we don't have ultimate reality and conventional reality. That kind of gradation or layers of reality we don't have. So we have to critically examine this kind of. They have found in laboratory experiments in recent times where the quantum teleportation has found, or has, even in Chinese scientists, they have done experiments where they found a correlation of an entity called non-local correlations. So this is because due to quantum entanglement. So quantum entanglement is real. I am emphasizing gross matter. What is meant by subtle matter and gross? We don't know it. Second is the intrinsic property in quantum theory and emptiness in Buddhism. And then the philosophy of relations and what the laboratory experiments say in modern physics.
Thank you, Professor Sisiraji, and Buddhist philosophers. Now, I would like to invite and before that introduce Dr. Puja Deb, Buddhist and Tibetan Studies at the Namgyal Institute of Tibet. Nagarjuna's philosophy of emptiness, specific periods, this teaching and research experience with a range of institutions, including the University of Delhi, Jawaharlal Nehru University, Tibet House, YMCA, and themes of such as practice of emptiness, Buddhist approach to inner and world peace, Buddhist international conferences and seminars. She is German, and Dr. Puja Devra, please.
So you point here, and where do you point for the light? Hello, good afternoon. Can you hear Naman Santalla for kindly introduce Chair Geshe Dorji Damdullah and Tibet House for giving me this opportunity. So my topic for today's talk is distinction between partless particle and nuances, although the time is very limited. Okay, so let me begin by what I think we all will agree with what Buddha Shakyamuni, we all yearn for ourselves and the universe that in the commentarial tree, extensive explore I go to, and My topic revolves around the physical matter, but this is not the universe is not something which is confined to only the physical matter. In fact, anything that exists, as I said, it's known as phenomena, and the phenomena can broadly be classified under two major categories: composite phenomena and the non-composite one. So the composite are the impermanent phenomena which change momentarily, whereas the non-composite one are the phenomena that exist but are devoid of change. And then within the composite phenomena means they change momentarily, changed a bit, maybe different interface. Okay, so it's the third one is non-associated compositional factors. So the form, so the my itself, and before I go there, so let me just define the form as it is defined in many of the Buddhist treatises. It is said that form is something which is consist of atomically composed things. So here the word atomically, don't take it literally as it is accepted in physics, but it's here it simply means particles. So something, three particles, and then the objects of our five senses, and then also the four great elements, and also the five physical sense power, which is solutions of the mind, which we call mental factors. Then in the third category, it's a very interesting one. So anything which is composite or anything which is impermanent in nature but does not belong or does not fall to the category of form or mind should fall to the category of non-associated compositional factor. And then the non-composite one means, as I said, something that exists but is devoid of change. So now the topic of today's talk is around form. Okay, and then as I said, form is something which is consist of particles, or we say that the fundamentality and visual forms such as this mic, flower, this hall, they all consist of the particles as their fundamental building blocks. So to really understand the notion of the physics, namely Vaibhashika, Sautrantrika, Chittamatra and Madhyamika. And within Madhyamika again we have two that I'll be explaining a little later. So now the first two schools, Vaibhashika and Sautrantrika, although they do not accord in all their presentations of tenets, but there is something which they accept unanimously, that is the acceptance, that is accepting something called partless particle. So what they say is that the physical matter that we experience around us, the fundamental building blocks is not only particle, they call it partless particle. And what is that partless? So as you can see, it comes from Acharya Vasubandhu's Abhidharma Kosh, Treasury of Higher Knowledge. A partless particle, a syllable, and a single moment are the smallest unit of matters or word and time. So if we just focus on the smallest unit of matter, the text says it's partless particle. And then what are the different qualities and the features of this partless particle? Several traits of this partless particle. Let me read it for you. Combination of other particles. And it is composed of at least 8 substances. What are these 8 substances? So the text says it is composed of 4 great elements. So this is the description of the partless particle, which is accepted by first two schools, Vaibhashika and Sautrantrika. Okay, now before I go into partless particle more, those 8 substances, 4 are great elements. 4 great elements: earth, water, fire and air, and the 4 element derivative. So the 4 great elements, what are the essential nature of these great elements? Tt is the essential nature and the function is to support. Then the water element, moistness, and the function is to bind. Then the fire element, the essential nature, and the function is mobility given to the particle. And then why they are called great, there is a reason for it, as it is of particles or maha. Then why they are called elements comes from Buddha Sutras, and that how from this very minute partless particles or from these elementary particles which are microscopic in nature, how this agglomeration means how from the micro elements the macroscopic physical world comes into being. So in Extensive Display Sutra, this is Buddha's discourse, and also in Abhidharma Kosh, which is a treatise written by Acharya Vasubandhu, so there is a mention of the atomic agglomeration that proceeds by the 7 particles, they make a bigger particle when it comes in combination. For example, the 7 subtle or partless particle, they make 1 minute particle, then again 1 minute particle makes 1 subtle particle, and so forth. And then again, you must be wondering why this number 7. So this number 7 is just referring to how these particles are arranged. So, and 1 below. So therefore, physical dimensions of sun ray particle, dust particle, particle of the rabbit ear, like this. So this is something that we can refer to if we want to know more of the principle of atomic agglomeration as explained in the Buddhist treatises. Okay. And then just to mention that this is not the only principle that is mentioned. In fact, there is a mention of the principle of atomic agglomeration, which increases by the six-fold increment. So different presentations are there that one can, Bhashika and Sautantrika perspective, physical matter is finally composed of the particles, and then the final particle, they call it a partless particles. And then, but according to the higher Buddhist schools, namely Madhyamika, they also accept that particles, okay, this is something commonly accepted by all the schools, that particles are the building block of, so when it comes to higher Buddhist schools or higher schools of Buddhist metaphysics, they reject the presence of the partless particle. Great Nalanda scholar who was a direct student of Arya Nagarjuna. He, and also a well-known formulation of the rejection of partless particle is, so this is a presentation which is accepted by the higher Buddhist school. So let me clarify once again, they accept particles but do not accept partless particle. And the reason comes, a very rational reason is coming from the Acharya Vasubandhu's treatises. So before I read this, let me just quickly explain this to you and then I'll be reading the verse. So Acharya Vasubandhu is arguing that however minute a particle is, it should have parts. Why? Because he millions and trillions of particles. In science, you may call it electron, proton, neutron. Let's say they are composed of millions of particles. And then from this pool of particles, if you just point one of the particle as the central particle. So let me clarify. Again, none of the particle is central with respect to other particles that are surrounding it. So let's say you mark one particle as the central particle, and then Acharya Vasubandhu says that this particle must that the central particles has 6 parts within. But this, when this is said, then the proponents of the lower school, where Bhashika and Sautantrika, they were not very happy. And they said, yes, we also agree that the central particle should be surrounded by some particle, let's say 6 particles, 4 particles in the 4 cardinal direction. Central particle is surrounded by 6 other particles, then it should have the 6 parts within. So to that, again, Acharya Vasubandhu rebuts by giving very rational reasoning. More clearly, let me use this I picked up to make things clear surrounding 6 particles. So let's say when this is the arrangement, so Acharya Vasubandhu is saying, so this central orange particle is surrounded by the 6 particles. It's a clear indication that it has at least 6 parts, right? So it cannot be partless. But then the opponents, or let's say the lower Buddhist schools, they say, no, this does not prove they have 6 parts. There is an absurdity. Have parts within. Then the orange particle, as we can see, touches the green particle in, above and does not, okay, so orange particle has a part which touches the, but not the particle in the south direction. And then, but if you say that, okay, it has a, so it's a clear indication that it has a part which touches the orange particle, central particle in the north, and the particle in the south, they two will meet. Why? Because there are no 2 parts of the orange particle or the central particle which touches them separately. So now he says that the very fact that the orange or the central particle has a part which touches the north, particle in the north, and does not touch the particle in the side or the part of the partless, which is partless particle, should be touching the particle in the north and particle in the south. Then the particle in the north and the particle in the south, they two will meet, conflating into each other. And then we all will agree difference is seen because the particle within a mountain, they do not conflate into each other, right? So, but if we accept the partless particle, then the surround. So now it says, because of being simultaneously surrounded by 6 other particles, the central subtle particle is found to have 6 parts. If these 6 parts have this explained, if we accept a particle to not to have any parts, then the surrounding particles will keep on conflating into each other because the central particle does not have the parts which touches them on different sides because it does not have any parts. Okay, so with that, he rejects the concept of the partless particle. The 2, Swatantrika Madhyamika and Prasangika Madhyamika. Okay, so now before I go to Swatantrika Madhyamika school, which is the highest Buddhist school, it is not highest because of any hierarchy or something. It is highest because it presents the subtlest of the ontological reality or the ultimate reality of the phenomena. Okay, so now Chittamatra, before I go to Madhyamika, so Chittamatra, fundamental philosophy is Chittamatra. nothing exists external to the mind. So this is their fundamental philosophy, that everything is the nature of our own mind and nothing exists external to the mind. So then, do they accept physical matter or not? So within Chittamatra, scholars differ, of course. Some scholars say that the very fact everything is just the nature of the mind, you cannot causality and externality do exist as particles, and they have the same traits as explained by the lower schools. Means they are the building blocks of the they are the building blocks of the microscopic physical matter. At the same time, they are composed of 8 substances. So within Chittamatra, the scholars differ. In English is the autonomy middle way school. So this school accepts that the fundamental philosophy is this opening note that they excite. So this is their philosophy. And again, do they accept partless particle? As I said, they reject the partless particle, but they do accept particle as the building blocks of the physical matter. And then within Swatantrika, again, there are nuances. Since the time doesn't allow, I may have to rush. That within Swatantrika, there are divisions, matter in line with reason it presents the subtlest. Go there. Let me just make a clarity of my topic is also related about the indivisible particle which are accepted in physics. But then, if you accept I would like to share accepted in physics, because the indivisible particle as physics presents is a particle which you cannot physically divide. At the moment, you cannot physically divide it into parts, right? But Acharya Vasubandhu's rationality and the reasoning is that however minute a particle is, at the moment, indivisible. Okay? Now the next is the final part of my topic is intrinsic particle. So here, why did I bring the Prasangika position is except for all other Buddhist schools, Vaibhashika, Sautantrika, Chittamatra and Swatantrika Madhyamika, it's only Prasangika Madhyamika which refutes the existence of intrinsic particle. All other schools, they accept that particles exist, be it partless particle or parts having, these particles also exist intrinsically. But the Prasangika, which presents the subtlest of the ultimate reality of phenomena, they say that, so as Professor Sisir, two truths, that okay, conventional truth and the ultimate truths, and you see the harmony of these two truths. So what is being said by Prasangika Madhyamika is not analyze these particles closely, cross to find out the ultimate name. Madhyamika Karika does not talk about the conventional nature of the particle. As I, whichever, dimensions of the particles is shared by, in science, they will accept it. But what is the ultimate nature of these particles? Then they come up with the theory that, okay, ultimately, nothing exists intrinsically. The very fact, in fact, if I may cite this statement, that emptiness of intrinsicality is the intrinsicality of the object. So in other words, that nothing exists in the person, this ultimately, how this person, does the person exist the way, not air, not space, not also consciousness, and not all of them, where is the person out of those? So basically, here the question is not about whether the person exists or not. If you are still not over of this question, then you are not, how does it exist? Does it exist the way it appears to us as from the object? Or does it exist subjectively through the mental imputation? The person is composed of 6 elements, and none of the 6 elements is the person, and you do not find a person which is different from these 6 elements, is a clear indication that the person does exist, but it does not exist the way it appears to us. It's only by dependence on the subjective imputation that the person makes a sense, and not from the object side. Because if the person does exist from the object side, the more you go closer to the object, you should, or the person, you should be able, just as a person is not truly existent, because when you go closer to the particles, if you don't analyze the particles through ultimate analysis and remain on the level of conventionality, then every feature of the particles will make sense. Means, as Professor Suchiroji was saying, there are extrinsic properties, intrinsic properties also. But when you analyze the particles are composed of particle which is different from the subatomic particles. So therefore, particles, when you go closer, examine through ultimate analysis, they do not have any intrinsic nature. Means they do not exist intrinsically. Particles do exist, but do not exist intrinsically. So particle existing, having mass, charge, weight, this is all the conventional nature of the particle. Whereas when you subject the particles to ultimate analysis to find out how do they exist, then as for this school, it comes from, so it, for none of these is there a creator, subject intrinsic nature. But does this mean that they do not exist at all? The answer is no. So Buddha said they are posited by the power of thought. It is through conceptualization that the world is imputed. Nothing exists from the object's side, but things do exist and functions efficaciously by the power of the mental imputation.
question and answer session. So we'll take 3 questions because of time limitation, right?
My question is to Professor Satish K.S. sir. So like you mentioned in your talk that person we are not aware of and we have termed it as dark energy or dark particle. So like I'm unable.
It's not that we are not able to perceive it, we see it indirectly. That is, for example, if you observe the way the galaxies and the stars move in the universe, you know that there is more matter than we can see in a way that further seen, but in what it is. This matter that we do not see has a gravitational effect on the stars and the galaxies, but we conventionally see on things, gravitational effect on things, but not otherwise.
So sir, why is it so difficult to
light, whatever interacts with us, not just gravitationally but otherwise also, we know, we believe gravitationally, but that's all we know about.
You mentioned this variation or variable speed of light in different universes, probability distribution of C. So you said
there is a probability that she can take different values.
Which
speed of the light?
Speed of light
can take different values according to interpretation.
I haven't heard about it.
No, you should read a very intriguing book by Professor Mittelstadt. He is a very famous German physicist. Recently he...
Okay. I mean, this is not something that normal physicists believe in.
No, because, I mean, you can check into the Buddhist framework, because when you go to, smaller and smaller, in the beginning, or normal quantum mechanics, they say wave and particle. This is the ontological. How the scholars, they thought of field concept.
I agree with you, sir. This word may not come as a field concept, or I'm sharing my concept of energy is there. Concept of energy moving on a very subtle level. Especially in tantric texts, there is a mention of a very, very subtle energy. No contradiction. So what they say is not that the energy comes through the conventional reality of physical matter. They have evolved so much. So we should be accepting that how it is, as sir was explaining, that Higgs boson and the other particles, and especially the entanglement theory and other things. But the question is not about the conventional reality. When it comes to the ultimate reality of this energy also, this quantum, field also, then there is a different method to analyze that how do this exist? Do they exist the way they are perceived as nothing, no role of the mind and the object existing purely from the object side? Or there is that analysis. The frame of reference is very different. So it would be accepted, the field and the other things, but what is the ultimate?
Conventional reality.
Yeah.
That's the whole problem.
That's I agree. But if we understand, I would say I agree with you. But if we understand the nature of these, it's not Buddhistic, to be very honest. Ultimate analysis and
no, the Jagat is Maya. Enlightened, you cannot say like that.
In Buddhism,
so methodology is different.
Yes, I agree with you, sir. But in Buddhism also, it's not that only when you're enlightened you can perceive the ultimate reality. Way before that, through the inference, as sir was explaining, indirectly using the inference. I agree with your question, but what I'm just as a who is sharing Buddhist perspective, what would be helpful to resolve this is to and what do you mean by ultimate analysis? So I'll just cite what R.N. Nagarjuna said again in this very well-renowned text. What do you mean by ultimate analysis? It simply means, so he cites a very well-known statement from him is, if the mirage were to be water, why not those close by the mirage see the water? So what he said is that if you really want to know the ultimate nature of this mirage, what do? You cannot stay behind, you have to cross the border of convention and go closer to the mirage. Only when you go close enough, and then you see that, okay, it does appear as a water, but it is not water. Then only you realize that what appeared earlier as a water is illusion-like, or it is not intrinsically there. So likewise, he said that all phenomena, if you analyze through ultimate analysis, meaning where you cross the border of conventionality of those phenomena, then you get to the ultimate nature. And then this is done with a purpose, not with the purpose of that, okay, apparatus is such, or we have a limitation. Not, it's to see that, okay, how does the world exist, because it affects our emotional world. And because it affects our emotional world, we should know that purpose. These two analyses were explained by Buddhist Shakyamuni, and nothing, so that's my take. What would be really helpful is to really understand what do you mean, and what is the border of analyzing something through conventional analysis and analyzing something through ultimate analysis, how they are two different frame of reference. Then only we'll be able to see that, okay, this is not something Buddhistic or religious, it's simply two frame of reference that
there might exist like string theories. They say string is the ultimate entity from which you can build up the whole universe. So, but we are not having this kind of concept, that border between conventional and ultimate, because we don't know what is ultimate.
If the ultimate reality is not comfortable for the physicist, then we can say like nature of reality, that is acceptable, right? Yeah. So if we can go to understand the nature of reality at that level, then we have to have a different perspective. And that perspective initially has to be developed through inferential kind of processes, and then through experiential processes, and then through meditative procedure, and then eventually, ultimately, not ultimate reality, but ultimately, one can experience that. Mm-hmm. These are the processes.
That is the dreams of physicists like Einstein.
Yeah, and then we are in the same...
Make a theory of everything, but they are without this.
But after all, it is, it has why it is important to understand the nature of reality is to change our perspective. And to change our perspective is required in order to change our suffering into happiness.
Or do you think it's innate nature of being?
Innate
nature of being.
Innate has a kind of imposed meaning. Yeah. So as you said, really, rightly said that the intrinsic nature. So we have to see, because in Sautantrika they use nature. In Vaibhashika use nature. Sautantrika use nature. Vijnanavada use nature. Madhyamika use nature, all in with a different meaning. So we have to understand the context, and then within that context we have to explore and try to understand. Yes.
Yeah, that's a dialogue.
That is why the dialogue is very important, right? Yes.
This is for professors. This is Roy for Buddhist scholars. And before I give my own opinion about on those three questions, I would like to clarify what we mean by subtlest particle. So subtlest particle means a particle, when you break it down mentally, having the mentally perceivable spatial dimension beyond which you can break further. So that's what we mean by subtlest particle.
No, but our answer is that
scientific, maybe understanding of the waves, particle, energy, whatever it is. Our subtlest particle may be more subtler than that. So whatever, even if you don't have the concept of subtle particles, I'm sure when you say waves, particles, energy, they have spatial dimension.
Yes.
So that's...
No, both particle and energy, they have...
So they occupy their own space, spatial dimension. They occupy some space, right?
Yes.
On which other, for example, if it's a particle or a wave, it's its own spatial dimension, on which other wave cannot take their place, right? It's its own spatial dimension.
So this object has also occupied space.
Yeah, of course,
Can
of
I
course,
say
of
this
course.
subtle particle?
Yeah. No.
Then?
Subtle means something which does not appear, which is not perceivable to your growth. Get to these waves, particles, energy that you have. So,
listen, say bacteria. Bacteria we cannot see through our naked eye, but we can see through microscope.
Sentient or not. If it's not sentient, then we have just to consider the physical
this is
body of
biologically, I mean, no doubt is there what is bacteria.
So it doesn't matter. That's what
even a big galaxy. You cannot see through your eyes, but a telescope you can see the galaxy. Do you think that is a subtle
Well,
object?
when you go close to a galaxy, you can see it, that's because of the distance.
Yes.
When the object is close to your eye, even though, for example, this consists of so many particles,
Yeah.
the subtlest particles, even if you take it close to your eyes, you won't be able to see them.
No, that's why I say that sensory eyes plus instrument.
If I may answer, what is the difference between gross matter and subtle matter? That's one of the questions. So gross matters for us, Buddhist philosophers, are those which are beyond our senses.
Okay.
And then subtler, you said the subtlest waves and so forth, they have their own intrinsic property. And in Buddhism, you don't accept any intrinsic nature of any phenomena. So how do you reconcile these two? So in my own understanding, when you get to the intrinsic property of the subtlest wave, you get to that by using your microscope, and then you see that intrinsic, the word intrinsic, if I get it properly, you mean to say that intrinsic property means the property which is inseparable from that wave, which doesn't change. It's inseparable. It's inherent part of that particle. So that's for that you are using the word intrinsic on the object.
No,
that's why we say they do not exist intrinsically or from their own side, but there is no contradiction. So
there is contradiction in the sense that even His Holiness Dalai Lama said, if modern science proves something, then we should be open to accept it.
Yeah.
Now, in our case, in science, we have shown that no, the electron has intrinsic property like charge. You cannot get another electron by converting this electron to that entity.
Yeah, that's okay. For example, the impermanent nature of us, that's also inseparable. So that's also our intrinsic property, even if we are gross.
No, we are not saying that earth has intrinsic property. In philosophically, we say solidity and something.
All right. And anyway, I think we just need to get different connotations of what intrinsic means. Then you said, okay, the relation between two electrons, two protons.
Yeah.
So there is a relation between these two, and as per Dhammakiti's understanding or positing of two kinds of relation, it doesn't fall within any of these two, which is true. And we do not subscribe to the ultimate reality as proposed by Dhammakiti. For example, the relation. So the definition of relation is if two things. Okay. First, we have to see if when we are speaking of relation of two different entities, whether they exist simultaneously or subsequently. So if this occurs subsequently, then if because of the cause being becoming non-existent, if the result cease to exist, that means the cause impacts the existence of the.
No, here.
No. That's what I'm saying. Existence of the result is dependent on the existence of the cause. That's why they are related. Now, if they exist simultaneously, for example, this mass and its color. Okay. If also impermanence nature of this mass and this mass. So if this mass exists, the impermanence nature of this mass exists. If this mass impermanent exists, it exists. But if the mass stops to cease or stops to exist, then its impermanent nature will also cease to exist. So because of that, even though we can say impermanence, that is the quality of this mass and the mass, there are two things that exist simultaneously and they impact one another. Because of that, they are related. So from that perspective, we cannot say two protons. If they impact one another, because of which if one proton's non-existence or cessation of one proton will cause the cessation of the other proton, then we can say they are related. Otherwise,
this happens because if we measure the property of one proton, then immediately you can say, even without measuring, what will be the property of another proton far away from this. So this is not causal relation, because you know nature of the relation, apart from causal relation, there may be other type of relation.
Okay, that's true. Yeah, that's true. Yeah, thank you.
Okay.
Hello. Hello, sir and ma'am. I have a question. In all these talks about intrinsic quality and emptiness, I wanted to ask if we are really talking about the duality of mind and body, are we separating both, like separating the mind and the matter that's making up the body? And with that, I want to ask if it is really separate from the physicalism of physics, which thinks of the world as a physical object, as a something coming about from the interaction of forces and matters. Why can't the mind itself be thought of as a natural product of the psychological and physiological and neurological faculties that we have as a human being, and probably other animals do have too?
Okay, this is very interesting question. I can end this with a very small story. When I was in USA, on my side of my office, one very famous neuroscientist, his name is Carl Pribram, who proposed holographic theory of brain. He used to come to my office once in a week, and he had only one question to me. He said, "Tell me, where is my mind?" And he believed that it is in my neuronal architecture. So we don't yet, as a physicist, we don't know what is mind. That I can tell you. Then mind-body problem comes later on.
Thank you very much, everyone. And that was the last question. So I would like to thank Mr. Chairperson Venerable Geshe Samdela and the respected guest speakers. And I would like to request Mrs. Joya Roy Ji to kindly do the honor and present the souvenirs and the white scarf to our chairperson and our guest. Please welcome Joy Roy Ji. Venerable Geshe Samdela, Joy Ji, I would like to request you to kindly offer the scarf to Venerable Geshe Samdela. Thank you very much. And then we have Professor Sissy Roy Ji. And now we have Professor Satish KSG. I would like to request to kindly offer the souvenir and the white scarf. And now we have Dr. Pooja Dabrala. I would like to make a quick announcement, Gishla. We'll have a quick photo session on the stage. So, just now. Just now, sir.
At the end of the day, or?
We have already concluded, sir.
Okay.
Right. No. We have a quick tea break session for 15 minutes, and afterwards we'll resume the last session of the day. Thank you very, very much, everyone.
Um, Good evening, everyone. Welcome back to the third session and the last session for today. My name is Tenzin Kunkyap. I'm the Nalanda Courses Coordinator at Tibet House and the Assistant Secretary. The topic for this session is the first one, quantum correlations and non-locality versus theory of relativity in Prasangika Madhyamika. And the second is Buddha beyond quantum, self-inquiry with the language of physics and the foundations of calculus versus convergence and divergence between quantum theory and middle way philosophy and Buddhism. So to chair this session, I would like to request Professor Ashok K. Jain, Honorary Professor, MIT University, Noida, to kindly come up on the dais. As for the speakers, I would like to call upon Professor Atul Kumar, IIT Jodhpur, Venerable Geshe Ngao Namla from Office of His Holiness the Dalai Lama, Dharamsala, Dr. Abhishek Maji, Physics and Applied Mathematics Unit, Indian Statistical Institute, Kolkata, Mr. Loris Namgyal, Senior Research Fellow, UCG, Department of Philosophy, Punjab University. I hand over the session to our chairperson. Let me briefly introduce Professor Ashok K. Jain, IIT Roorkee from 1979 to 2018, and retired as a senior professor, followed by emeritus fellow. Presently, he is the honorary professor and advisor at MIT University, Noida. He has made many significant and original contributions in several areas of nuclear sciences, having published more than 150 papers and co-edited, authored students for his simple and down-to-earth expositions in teaching and research, and has delivered hundreds of talks in India and around the world. He is currently on editorial board of Pramana, the Journals of Physics, Indian Academy of Sciences. Professor Jain has a deep interest in the philosophical and spiritual traditions of various religions with a focus on Shamanic traditions, and has written several articles and has received the following awards for his work on the English translation of Jain canons. The first one, Acharya Sumati Sagar Smriti Award in 2009 and Acharya Gyan Sagar Smriti Award in 2015. With this, I request our chairperson to kindly proceed with the session.
Thank you so much. I am really very much thankful to the Tibet House for inviting me and giving me this opportunity to meet so many scholars from Buddhism and science. The opportunity came rather quickly, and I was invited by Tibet House on the instance of Professor Sisir Roy. I don't see him here, an old friend. And topic of this session, which is the last session, and I'm really glad that I still see so much of audience here in the last session. They have not disappeared. Thank you very much. And this is very rare actually. I go to a lot of conferences, chair many meetings, and by the 4 o'clock, half of the people have disappeared. This is a normal thing. So, the topic of this session particularly, the conference is on quantum physics and Buddhist philosophy, but this topic, quantum entanglements, for experiments which were done much earlier, but they have now been recognized and accepted as the kind of hallmark. and therefore the prize came. The prize was seemingly, it seems very simple. From a single source, 2 photons are emitted. Photons are nothing but the particles of light. There is a lot of discussion here on particles and subtle particles and so on. And these 2 photons, they emerge from the same source. That's the beauty. So they are related to each other. They are kind of brothers. And as they travel, they don't forget each other. They are real brothers. They keep the memory on and on. If something happens to this one, the other one responds immediately. And why this is very strange? Because physics forbids transmission of any information faster than the speed of light. You cannot send any signal faster than the speed of light. That is the limit of our physical world. But here, the other electron immediately knows that my brother electron has suffered some knockout or something, and he responds immediately, in an instant. So that is non-locality. And that is also entanglement. They are still related, even if they have traveled large amount of distance, 10 kilometers, 20 kilometers, and so on. So this gives rise to a very strange idea also, because the present concept of universe is that it started from a Big Bang, from a single point source. And as Professor Roy was telling, in the beginning there was only Planck universe, where only Planck distance was there, Planck time was there, and that was very small, incredibly small, 10 raised to the power minus 43 seconds. The time that we can measure right now, the scientists can measure 10 raised to the power minus 17 seconds. That is the precision of atomic clocks. Nuclear clocks may be coming soon, and then the precision will go up to 10 raised to the power minus 19 seconds. But 10 raised to the power minus 43 seconds is a far cry. We don't think we can ever reach that. So, when it started from a single point, probably everything was coming from the same source, and therefore everything must have been correlated, even now. So that idea is already reflected in some of the discussions and some talks. The whole universe is kind of interconnected. Quantum mechanics is my bread and butter. I eat it every day. I am still a practicing physicist, a nuclear physicist, and I publish papers every couple of months. I have students, I have postdocs working with me. So I use quantum mechanics every day. Contrary to what people think, that is a probabilistic interpretation, therefore probabilities mean you will not be able to tell things precisely. The point is that quantum mechanics is probabilistic, but it gives you precise results, very, very precise results. That is the beauty of it. Second thing is, the quantum mechanics that we do, it doesn't work in terms of probabilities. We bring it in terms of probabilities for ourselves to understand, to interpret. It works in terms of amplitudes. And amplitudes are something that we cannot handle, cannot measure by any equipment. Not only that, there is one more complexity in amplitudes. Amplitudes are complex. Complex means they are not real numbers. There is a real number plus an imaginary number. There is a real component and imaginary component. Imaginary component means under root of -1 is attached to it. Now, how do you measure that? There is no equipment you can use to measure it. So, quantum mechanics operates at a very subtle level in terms of complex amplitudes. And then, to make sense out of it, we do the squaring. We take its mod square, and then it becomes, imaginary thing also becomes real, and then we find the probability, use these probabilities to do the calculations. And we can calculate things very precisely. I can tell you the hydrogen atom atomic energy levels to the 4 or 5 digits very precisely. So, this is the beauty of this theory. Now, this theory was designed not for living beings. As a professor, Honorable Vice Chancellor told in the morning, that we were all doing something to look inwards, to search ourselves, who we are, how we uplift ourselves, how we... And that these people then started looking into the material world also, but they didn't go probably very far. This is my feeling. Now, the science that we do, the quantum physics that we are discussing, this is mostly a Western science, originated in Europe, mostly. And they designed it to look at the physical world, not to look at the living beings, not to look at how human beings behave or how they, why they feel unhappy, what happens to their in this birth or next birth. This was not designed for that. But they have also started looking into it now, using the same concept, going into that. Now this makes it very interesting, because there are philosophies like Buddhism, Jainism, Hinduism. Hinduism, you mean a number of philosophies are there in Hinduism, large number of them. And they were all looking at the human aspects, living aspects. So, they are now beginning to meet, and this conference here is an example of that so many monks are sitting here, Buddhists are sitting here, they are taking names of protons, neutrons. Earlier they will only chant the mantras and so there is a change, of course, and things evolve in this way. Definitely they are conveying their outlook, we are trying to grasp it, and the scientists are giving their outlook. And that has started in recent decades only, some decades, and it is expected of every human being who is out searching there for new things. That is the beauty or kind of, what you call the, we strive for it. That gives you a kind of excitement. We will find something new. So, I don't want to take much time because there are 4 speakers. Wave function, all the description in quantum mechanics is in terms of wave functions. A very interesting concept that we learn when we start learning quantum mechanics is the free particle wave function, where there is no force field, nothing is there. And we know if there is such a particle or such an entity, its wave function will spread throughout the universe. It will not be confined anywhere. And this is a very interesting thing. It spreads out throughout the universe. I was born in Banaras. There is one person here who was born in Banaras. Who is there? I was born. Yeah, he is there. But you have not lived there for long. I have lived there for very long. Very long? Yeah, till my BSc. Oh, BSc. Okay. So, good enough. So, I used to do a lot of meditation in those days. I was very good at meditating. And I learned it myself. I had no guru. And I used to read books and do meditation and sit down for hours. And I knew yoga, so there was no problem in sitting down. Then I felt that sometimes I could feel that I am not here. I have spread out. And I also felt that I have spread out anywhere. I am everywhere almost. This was the feeling that I used to get. And this happened when I was in deep meditation. And then I compared it with my free particle wave function. It is everywhere. So that makes a lot of sense to me, that as you free yourself, you do not belong to a place. You spread out, you merge with the universe probably, or whatever happens. Something happens, definitely, that those who practice it, they can tell. So, this is one analogy that I find very nice and very interesting all the time. Second is the concept of this shunyata has been discussed here quite a bit. And I know that in Buddhism this is very important point, that you try to reach the shunyata. In quantum mechanics there is concept of vacuum state. Now, whenever we do calculations, we build models or we try to do some nice, kind of, any interpretation of data or something, we are doing some calculation. We have a vacuum state. Then we have various operators and we create things out of it. Vacuum has everything. It has nothing and it has everything. This is the concept of vacuum in quantum mechanics. And vacuum changes from system to system. It's not that it's the same vacuum here. It could be one vacuum when you are doing a hydrogen atom problem. It could be another vacuum when you are solving Schrodinger equation or something for, say, a carbon nucleus, and so on. But some intrinsic properties, as Professor Cicero was telling, they are same, unchanged. Some basic conditions are there which are required to define the vacuum. They remain. These are called the kind of invariant properties, or sometimes, particles also carry such properties which we call quantum numbers. So they define like what is an electron, and this is the quantum number, must be if an electron is there, this must be the quantum number, there is no other way. And whole theory, not only atomic physics, whole material science built on that. People design new materials based on that. New materials are designed. What properties you want, they now ask. We will design it and we will make it in the lab and give you. This is how new materials are emerging. And they are changing our lives, our devices, our aeroplanes, our rocket, everything is changing. So, science has evolved tremendously, and let us take note of it, and I hope that the speakers here have a lot to say about this. And so I invite first of all Professor Atul Kumar, who is from Varanasi, born in 1979. I left Varanasi in 79. Yeah. No. There is nothing wrong or right time. Time is time. I left Varanasi in 79. And he is BSc, MSc, etc. from various universities, IITs, and PhD from IIT Madras. And he has done So he is all quantum mechanics. So I invite Professor Atul Kumar to present his talk. Please. 20 minutes.
Sure. For the introduction, I wish I was all quantum mechanics. Unfortunately, I'm not. So, inviting me for this lecture on quantum correlations and non-locality. So, just before Professor Sisa started his lecture in the previous session, he said that you might be feeling sleepy because you had very good lunch, right? I was thinking I had a bigger responsibility because you might be highly energized after having your tea. So it is my responsibility that I should not make you sleep. So I'll try to do that. Even if you are feeling sleepy, please show me that you are attentive towards the presentation. So correlations, as such, we do experience correlations in our everyday life. These are different from what we are talking about non-local correlations. Say for example, in the evening, if you are going out for brunch or so, it depends, the type of food depends on the money that is there in your pocket, or if there are rates which are slashed for your favorite food, right? The other example I can give you, like yesterday when I was trying to catch my flight, PM Modi was there in Varanasi yesterday. If you have seen the news for Varanasi or Kashi Tamil Sangamam, right? So he was leaving in the afternoon, and you could expect that traffic was diverted in different directions, and there were too many people who were moving out of Varanasi that time. And somehow I also did not calculate my time exactly, and I left my house almost 3 hours when 3 hours were left for my flight, and then I got stuck in the traffic, right? That is also an example that my presence in this conference then got correlated with that traffic jam, right? So I am present in this conference because the traffic gods had mercy on me. If not, then I would have been stuck there. I would have missed my flight, and I would have been in Varanasi, right? So a very different correlation with respect to what we are going to talk today here in quantum correlations and non-locality. So everything started long back in 1935, as many of the speakers have told in the morning. Like EPR started this argument, Einstein, Podolsky, and Rosen, raising the issue of quantum mechanics to be a complete theory, which was debated in a very healthy way philosophically by Niels Bohr. And then in 1964, John Bell, he, based on their assumptions of locality and reality that EPR proposed, John Bell designed an inequality, and he said that this inequality has to be satisfied if the assumptions of locality and realism was to be true. But it was found that there are quantum states which violate that inequality, and initially it was said that these are the non-local correlations. So any state that violates the Bell or Bell type inequality actually have non-local correlations. In the last 3 decades, people have realized the importance of having a paradigm shift into computing from classical to quantum, and a lot of theoretical progress has been made in terms of realizing quantum computing as a say method of computing, right? However, on the implementation part, there was not much progress until recently when IBM actually announced a 127 quantum computer, and they have also said that in a couple of years they will come up with 1000 qubit quantum computer and probably a 4000 qubit quantum computer by 2025. So at the heart of all this quantum computing and the advantages that you get because of fundamental laws of quantum mechanics is quantum entanglement and non-locality. So that is what we are going to discuss here today. So before that, I'll just like to give you a glimpse of IIT Jodhpur. So that's the first photograph at top left is what IIT Jodhpur campus looks like as of now. And this is the brain tree right just before that clock tower. So that is the brain tree. On the left side, you can see a tree which signifies the science component. And on the right side, you can see the electronics and neurons, which signify the technology. So it's a amalgamation of science and technology, and then men and women on the down. And this is a bit of wildlife that through this figure, a lot of funding has been going into the quantum computing. Even Government of India has started funding quantum computing projects from 2017 onwards. So this is a bit of a summary where we can distinguish the classical world from the quantum world, where if on the back side you can see this can be considered as classical bits, which can either be 0 or a 1, whereas the one running in front is a superposition of 0 and 1. So this cartoonic representation that you're looking at on your screen right at front can be represented as a quantum bit or a Q bit, which is a superposition of two different states, 0 and 1. So in terms of representation of quantum states, we can take an analogy when we are talking about a quantum state. What could a quantum state be look like? Say, for example, if you have a coin, right? If you perform a measurement on that coin, you either get a result that is a head or a tail, right? But in case of quantum mechanics, I have just put this head and tail in a bracket. Please don't worry about these brackets. These are just notations to show that these are quantum states. But whenever there is a head and a tail, please try to understand that these are quantum states for our perspective because of the general audience here. So from here onwards, I would probably not be using those notations of brackets. So qubits can be represented as heads or a tail in a quantum world. It's not head and tail in classical world. Just think about a quantum coin. There is no quantum coin, but just think about a quantum coin. So you can think about it that there are two possible states which could be head and a tail. And because of quantum mechanics, the basic intrinsic nature of quantum mechanics, these states can also be written as orbit linear superposition of heads and tail. So that you can see as A head plus B times tail. Right? This is what Professor Jain was also talking about AB as the magnitude, which are complex. And that is where when you take the absolute square of A square and sum it with absolute square of B square, it goes to 1 because the square of these amplitudes, absolute square of these amplitudes, in principle, they represent the probability, and probability must sum to 1. So a quantum state can be represented here as a linear superposition. And if you are thinking about a 2-qubit state, consider you have 2 coins. If you toss these 2 coins all together, there are 4 possibilities, right? You either get a head and a head here, a head and a tail here, a tail and a head here, or a tail and a tail here. These are the only 4 possibilities. And in terms of quantum states, then we have 4 possibilities, which is head, 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 tail, tail, head, and tail, tail. At the same time, as I said, because of the linearity of quantum mechanics, a linear superposition of these 4 possibilities also exists in general. So a 2-qubit state or a 2-particle state can be represented in this particular form, such that absolute square of A plus absolute square of B and so on, that sums up to 1. That's the probability, right? So considering that we are discussing polarization, I also thought that I'll just discuss a very simple experiment that tells us tells something about superposition and why do we say it. So in the first case, if you see, there is a polarizer 1, and in the second case there is polarizer 1 and polarizer 2, and in the third case you have 3 polarizers. If you look at polarizer 1, it is vertically polarized. That means it allows all those particles to pass through which are vertically polarized. In the we are just putting a polarizer in between the first and the second polarizer. In fact, that should be third polarizer, not this one. And y-axis, then diagonally somewhere here, right? Which is right at the superposition of x and y. So what happens in the first case, when an arbitrary polarized photon passes through the polarizer 1, it creates a linearly polarizer 2, considering that the projection of vertically polarized and the horizontally polarized, diagonally polarized polarizer in between polarizer 1 and polarizer 2, then you see that a horizontally polarized photon comes out. So if infinite number of such photons come in, the experiment shows that in the first case, half of the intensity reaches the screen. In the second case, no intensity reaches the screen. And in the third case, 1/8 of the intensity reaches to the screen. So how do we explain this? In the first case, if you look at it, when the half of the intensity goes through the polarizer 1, this cannot be explained based on a sieve model where the polarizer is only allowing the vertically polarized photons to pass through, because all the incoming photons are arbitrarily polarized, and there will be only very few number of photons that will be vertically polarized, so that intensity would be very low. It is only possible if and only if all the photons has a component in the horizontal as well as vertical direction. So if infinite number of such photons are coming in, you will see that half of the photons are vertically polarized and half of the photons are horizontally polarized. More like a coin, that if you do an infinite number of toss, 50% of the times you get a head and 50% of the time you get a tail. In the second case, we have already explained. In the third case, what happens is that the photon which comes out of the first polarizer is vertically polarized, and there is a component of it in the diagonal direction. So half of the photons again pass through, and then the vertically polarized photon just before the polarizer, the horizontally polarized polarizer, passes through that polarizer because one of its component is also in the horizontal direction. So half into half into half, that is where you get 1/8 of the intensity coming through, and the initial photons are having the superposition state. So, and why is it that quantum computing or quantum computers are important is because in our elementary classes we are taught multiplication algorithms. So multiplying two numbers is very easy. I can multiply two numbers very easy. It's like 3-digit numbers I can multiply. Tomorrow if you ask me to multiply two 10-digit numbers, it would be a little difficult, but I will be able to do it. But if you ask me to factorize a number such that its factors are prime numbers, that becomes a very difficult problem for me, because I have not learned efficient algorithms to factorize a number. So that is what quantum computer does. It immediately tells you the prime factors. Like this is one simple example. Another example that I have just listed here is in terms of a game, right? Because we are talking about superposition, so we should also understand why these superposition are important. So if I look at this game, which is called as a penny flip game, and game goes like P comes to Q and asks for help, and Q says that I have designed a game. If you could beat me in that game, I'll help you, otherwise I will not. So P says, okay, let me play that game. So game is that there is a coin which is heads up, which P puts it in a box and gives it to Q. Q doesn't look at the state of the coin, and he chooses couple of actions. He has the choice either to flip the coin or not flip the coin. Then he sends it back to P. P also has the choice either to flip the coin or not flip the coin, and then he sends it to Q. Q again has a choice either to flip the coin or not flip the coin. So if you look at the final result of the game, if it is heads up, Q wins the game, and if it is tails up, then P wins the game. I will not go into the details what happens, but classically there is a 50% probability that P wins a game, and there is a 50% probability that Q wins a game. So what happens quantum mechanically is coin can be represented as two-dimensional head and tail basis, and flipping a coin is kind of a sigma x operation. Not flipping a coin is not doing anything with heads up. He always applies unitary operations such that he can create a linear superposition of head and tail. Now, the moment he creates a linear superposition of head and tail, P being a classical player, he only has the option either to flip the coin or not flip the coin. So if he flips the coin, head becomes tail, tail become heads. So head plus tail by root 2 remains the same. And if he doesn't flip the coin, state is anyway same. Then comes Q, and he again performs the unitary operation, and he always gets a heads up. So in that sense, Q always wins a game. So that's a very simple example of how quantum superposition can help you win a simple game. Of course, there are many more intricate details, but we are not going into that. So now coming to quantum entanglement. What is quantum entanglement? So entanglement is a quantum mechanical phenomena in which quantum states of two or more particles have to be described collectively without being identified as individual states. So when we are talking about an entanglement as individual identities, this is a system as a whole. The whole entangled system is a single identity. We cannot say that this is one box and this is another box. The two boxes as a whole is a system. There is no individual identity of one box and the other box, or one particle or the other particle. The identity is of the whole system. So algebraically, what we say that if you have an entangled system, and if somehow you can factorize this entangled system such that you can write the individual states, then that state is not entangled. Whereas in the other case, if you cannot factorize, then the state is entangled. So we'll take some very simple examples in this case, just the representations. In the first case, if you see it is head plus head tail, say two particle state, can we say that this is an entangled system? We cannot, because this can simply be written as head into head plus tail, right? In the other case, if you have head tail plus tail tail, now this is also not an entangled system because it can be factorized as head plus tail multiplied with tail. So these are two individual identities, one for the first particle and one for the second particle. Now you look at this superposition state, right? This is HH plus ST plus TH plus TT. At one instance, it looks like it's an entangled state, but if you look very carefully, this is nothing but H plus T into H plus T. So it can be factorized as individual first system and individual second system, and in that sense, this is not an entangled state. But if you look at this state, this cannot be factorized as H plus T, H plus T, so this is an entangled state. Similarly, if you are looking at states like HH plus TT or HT plus TS, these are called Bell states. Now, these states are historically known as Bell states and are the key resources for many of the applications in quantum information and computation. So these are just pictorial representations of the entangled systems. Alternatively, you can also think about the two balls having two different colors. Now what you can do is you can have two boxes, pack the two balls in those boxes. The color of those balls can be the same, and then you send these two balls to Alice and Bob. Now Alice and Bob, when they open these boxes, before they open these boxes, they don't know what is the color of that box, but we know because we have packed those boxes, right? So I know what are the color of those boxes, and when they open those boxes, what colors they are going to get, right? That's kind of a classical correlation for me. But in quantum mechanics, what happens is if I pack two atoms, right? The entangled atoms, one into one box and another one into another box, and send it to Alice and Bob. Now, Alice and Bob do not know what would be the state or the color of those atoms. And at the same time, I also don't know when they will open what would be the state of those atoms, because the results would be very random, right? The particles itself are entangled. So if you look at the individual box, until and unless you open the box and see. So that's quantum entanglement for you. And these kind of correlations that are there because of quantum entanglement are defined as quantum correlations. So quantum correlations, as I said, EPR came up with this argument of locality and realism. And they said that where locality was like measurement of a particle in no way can influence the measurement of another particle, measurement results of the another particle. And in terms of realism is the values of measured properties of each particle have definite values regardless of whether we measure that or not. So when you measure it, what you see was actually pre-existing just before the measurement, which is more like a classical physics. So that was the argument, and based on the argument, they have shown that the quantum mechanics is not a complete theory, to which Bell in 1964, he gave a very simple argument by borrowing the hypothesis of locality and realism. He just came up with this inequality, which was AB plus AB dash plus A dash B minus A dash B dash, where A and A dash could be two different measurements that Alice can do on her particle, and B and B dash are two measurements that Bob can do on his particles. So if you carefully look at it, the maximum value for this quantity, which is AB plus AB dash plus A dash B minus A dash B dash, is plus minus 2. It cannot exceed that. So if locality and realism are to be true, then the overall expectation value of this quantity cannot be more than 2, whereas it was shown that for all 2 qubit states, this inequality is violated. And if the inequality is violated, that means that at least one of the 2 assumptions that went into the EPR assumption, locality and realism, are not correct. So I'll stop here with this message that when you are talking about non-local correlations, you are looking at an entangled system, whereas the individual subsystems cannot be thought as individual identities. It is the system as a whole that we are looking at, and the results that you are producing are not local but global results. So thank you on that note, and probably I'll leave it to the
Thank you very much, Dr. Atul. It was a very nice talk where he explained the intricacies of the 2-state entangled systems. I think there are any questions we will take at the end. Our next speaker is Venerable Geshe Nwang Sonam. As you can see, he is already a PhD, but his CV says that he is waiting for the formal ceremony. I hope that will happen soon, and he will be adorned with the this title. He has had a training of almost 22 years of monastic studies, rigorous training, and 6 successive years of examinations at Gelugpa Monastic University. So he is, and after completing all his examinations, he is waiting for the formal ceremony. Since 2008, he has also served as an English interpreter for His Holiness the Dalai Lama on various occasions, and since November 2016, he has been working in the office of His Holiness the Dalai Lama as one of the interpreters of His Holiness. As a professional translator, he also translates during his spare time, and two of his translations await release after the Tibetan New Year in February 2019. I invite Geshe Nwang Sonam to speak on the theory of relativity in Prasangika Madhyamika.
Good evening, everyone. First of all, I would like to thank Tibet House for having me here. I think, and then also I would like to thank our chairperson, Professor Ashok K. Jain, for the nice introduction. By the way, I actually have finished my graduation back in 2016. So, yeah. And also my fellow panelists and the audience, greetings to all of you. My topic today is Theory of Relativity in Prasangika Buddhist Philosophy. Before I embark on my own topic, I would like to take it from Professor C.C. Roy's statement in the beginning of his presentation. I have known Professor C.C. Roy for long and have utmost respect for his enthusiasm in the fields beyond his own fields of expertise. Now, this is not his position, but something that he quoted as being the word of Stephen Hawking. Philosophy is dead because the big questions it used to discuss are now in the hands of physicists. So the big questions that we philosophers discuss are in the hands of physicists. If this is a reality, I would be really happy for the physicist as a Buddhist practitioner. If I were to personally meet Stephen Hawking, although I'm very humble and just a general Buddhist scholar, I would still want to ask him, how do you define philosophy here? And what was his understanding of philosophy, and how far was it limited? Was it limited to the philosophy that thrived during his time, probably in England or somewhere in the West? Or does it cover Buddhism, Hinduism, Jainism? In other words, all those great Indian traditions, they are still thriving. So, although he's a great scholar, scientists, I disagree with him on this, because the big questions that we are discussing, that we are pursuing, is liberation or enlightenment. That is really big. So, with this note, I would like to start my presentation. First, foundation. So my topic is theory of relativity. Relativity, by relativity, what I get is things are not so concrete or absolute because they are relative. That's what we say. So by relativity, it means things are dependent on other factors, and because of which we cannot be absolutely sure about their certainty. So in that respect, I would understand relativity as being dependent on other factors. And through that, I get dependent origination. Otherwise, in our classical text, the classical texts that I've been studying, and I still study, are actually written in Tibetan. And the origin of those Tibetan commentaries are Indian works translated from Sanskrit. So these are not in English. So how you interpret the word relative, being a translator, I take the liberty of interpreting relativity as being dependent. So now, what is the purpose of establishing a theory for a Buddhist practitioner or a Buddhist philosopher? So first, philosophy is, if you look at our own existence as a species on this earth, we are not just humans. It's not just humans, but there are many other creatures, including animals and so forth, who do not have the sophisticated language that we have to address complicated philosophies or views. So philosophy means going beyond your senses to ascertain or to establish facts that are not easily tangible to us, that are not so easily understandable unless explored thoroughly. So because of that, philosophy is determining another level of truth. So in classical Buddhist texts, we divide reality into three categories. One is tangible reality, and then slightly hidden reality, and completely hidden reality. So tangible reality, that you see me as a human being speaking, that is tangible reality. We are in this whole inner conference that's tangible. You don't need to prove your own real life experience is stronger than any kind of reasoning to ascertain that. That is not it. Now, slightly obscured realities means based on our own understanding of tangible reality, using that as the evidence, then we infer things which are somehow beyond for the moment, beyond our sensorial perception. For example, if you see smoke in the distance, although physically you could see smoke with your eyes, you are not able to deduce fire, or you are not able to perceive fire from a distance. But since smoke cannot occur, is not born without fire, so from in that distance, that is the subject. Now the predicate is, what to establish is, there is fire, because there is smoke. So that kind of inference, what we call as infallible reasoning, we use this kind of reasoning to infer or establish some realities, just like physics. So, and we reach to that kind of firm, establish ascertainment about some things, like the impermanence nature of things, the emptiness nature of things. So that's what we do in philosophy. And then, based on the teachings that are verifiable through reasoning, and then there are some subtle teachings on karma of Buddhist hegemony, and we'll look at discrepancies within the same teachings that were taught earlier, same content, whether they contradict with the teachings that were taught later, whether the explicit meaning of those teachings contradict with the implicit meaning, and if there is any contradiction with the other two truths, tangible reality as well as slightly obscured reality. So if you don't see any contradiction from any respect, then we can say the subtle teachings on the subtle nature of karma, which are for the time being beyond our reasoning, we can believe in them because these are taught by the same person who insofar was so true with respect to the content of his the tangible as well as a slightly obscure truth. So that's how we develop faith in Shakyamuni Buddha. And the purpose of developing faith in an enlightened being is not just to venerate that enlightened being in the name of service. No, it's for one's own liberation. So with the pursuit of liberation, then you look up to them for teachings. So now the teachings consist of establishing reality. And then based on that reality, once you are convinced of that reality, then practicing that reality, and then being aware of the result beforehand, and then you practice, and then eventually you will get the fruition that you are seeking. So therefore, reality, as we Buddhist philosophers, as generally Buddhists believe, is not something established by Buddha Shakyamuni. So we say whether there is a Tathagata to descend on this earth to explain this reality or not, the truth of things, the realities of things are same. So emptiness, whether it has been taught by Buddha Shakyamuni or not, it doesn't depend on whether it's taught by Buddha Shakyamuni or not. The nature of things will always be empty. Now the word is the purpose. In Tsongkhapa, in praise of dependent origination, that's one of his spiritual songs. It is composed spontaneously upon realizing emptiness. Whatever degenerations there are in the world, the root of all this is ignorance. You taught that it is dependent origination or relativity, the seeing of which will undo this ignorance. So, as Mr. Chairperson has rightly explained earlier, we religious practitioners, we do not really look out to the external world in order to make products so as to build houses and so forth. We turn inwards and see whether there is something wrong with our way of thinking, or whether there is a discrepancy between appearance and the reality. Whatever appearance there is, are all they reliable, or there is some kind of mistake or deception in our appearances? If you really look at your thoughts, we have what we so called as the thought of I. Sometimes when you're drinking, you say, I'm drinking. That is okay. Although your hands or your body limbs, parts are not you, if these are moving, you say, I'm moving. So that means that kind of conventional understanding of thing, we don't need to challenge that. But sometimes when you are criticized by others, somebody says some bad names against you, and then you have, when you get hurt, what kind of feeling of I do you have in you? You do not think that the person is criticizing your body, or you do not think that person is criticizing your mind. You think that the person is criticizing me. And also when you are attracted to some other person, you might say, oh, the person physically not, when we say that person is not physically attractive, doesn't matter, I'm still attracted to that person. Well, the person is not mentally that intelligent or mentally not that compassionate. Still doesn't matter, I like the person. So you have an idea that behind the mind, behind the body, there is something concrete as I, tangible, pinpointable. So that is what we call as self-grasping, or for the time being I can say is synonymous to ignorance. So we try to fight that ignorance, because based on that conceived notion of self, then arises me and mine, independent self and independent mind, independent there, independent them. And then there is a demarcation, an attachment to what is me and mine, and then aversion to what is there and them. And from these emotions of anger and attachment, then we physically act upon them and create karma for ourselves and for others. So therefore, now deconstructing that ignorance is very important. If you're able to somehow see that the ignorance is a mind whose object or focus doesn't exist in reality, and then it's so assuring to meditate on emptiness. So if things are by nature independently existent, we cannot do anything about ignorance. Okay, ignorance perceives self to be independently existent. Ignorance perceives others to be independently existent. And if they are independently existent, we cannot do anything about ignorance. We just be content with that. So one of the Tibetan masters, Kundan Jambian, said, it is so fortunate that the nature of things are empty. And because the nature of things are empty, we have a solution to our ignorance, to our emotions, to our karma, and to our incessant birth in samsara. And there's a possibility of liberation because the nature of things are empty. So without this, okay. So establishing reality is important. So we have two kinds of reality. Reality based on appearance, okay? Unmistaken appearance, okay? Maybe deceptive, but unmistaken appearance, and then reality going beyond appearance. For example, even in our own physical world, if you look at things, there are different layers of subtleties. Some things are so tangible to our naked eyes. Some things, even if they are tangible, when you go closer to those things, they are tangible. From a distance, they are not tangible. So if you look at a tree from a distance, you will see the tree as very small. But when you go closer to it, the tree is very tall, very big. Which one of them, big or small, is the size of that tree, depending on from where you look at it. Not objectively tall or objectively small. If it's objectively small, wherever you go, from wherever you look, you'll see it as small. But that doesn't happen. So, ascertaining reality, there are two kinds of reality. Reality at an appearance level, going beyond appearance level. So, we divide conventional. Now, the truth based on appearance level, those we call as conventional reality. And then the ultimate nature of those conventional realities, that we call as emptiness. So, Dr. Pooja has already explained the classifications of conventional reality and how the lower schools assert an intrinsic property or indivisible particle, and how these are negated by the former schools, the higher schools of thought in Buddhism. So that I'm not going to touch. Now, for example, Chittamatra says nothing external, physical external, exists from their side externally, but they are just mere extension of your thought, mere in the nature of your mind, so merely mental. So the purpose of establishing that philosophy is to reduce our attraction to our external objects. Or external objects, they are just mental, mere mentally imputed. But you might think, okay, even if physical things are not objectively existent from their own side, well, the mind may have an intrinsic property. Then you again look into your mind. Where is the mind? Without the object, there isn't any subject. So subjective mind depends on object. So it is through dependent origination that you are able to get to emptiness. So ultimately in Prasangika, although as Professor Ngawasamdela has said, in Savatantrika Madhyamika, it's actually there is some existence from the side of the object, but not independent of the mental imputation. So they exert some kind of a intrinsic or existence from the side of the object, that existence is based on the imputation. So collectively, jointly, we can impute the existence of phenomena in lower schools, particularly, Savatantrika Madhyamika. But in Prasangika, nothing exists beyond appearance. So let me. So because of now, if nothing exists from their own side, how do we perceive self? And so we deconstruct our own perception of self by thinking, where is myself? Now, you are composed of these 5 elements. Are these 5 elements within you? If that is the case, how many you are there? If every part of you is you, then how many you could there be? Billions, trillions, if you break them into atomic levels, billions, trillions of you. But that conflicts with our usual conventional understanding of me, that I'm one person, one individual. So Prasangika or any kind of philosophical establishment of reality should not go beyond our usual conventional understanding of things. We maintain the truth that ordinary people with no philosophy understands. We do not counteract that. We do not breach that, maintaining that understanding. Then how things appears to us, as if from their own side they seem to have an intrinsic nature, existence from their own side. That we try to see whether
is the true or not. If that is the truth, then the more you search for it, the clearer would it become. So, although it does not exist in these sevenfold possibilities means, for example, taking a chariot. So, you have all these parts of the chariot combined together, and then you have a chariot, right? But when you say, the rein of the chariot, the wheels of the chariot, the carrier of the chariot, the upper layer of the chariot, the bottom of the chariot, and so forth. So all these are parts. So now, we try to say, where is the chariot? Chariot and its wheel. The chariot and its wheel, or its back, its front, and so forth. The chariot cannot exist as a distinct entity from the chariot, from the parts of the chariot. It cannot be a distinct entity, because otherwise you cannot address the chariot in relation to its parts. So, as completely distinct, unrelated object, you cannot speak of the chariot unrelated to or without taking into consideration the parts. Now you come to the parts. Are the parts of the chariots the chariot? Then how many parts could they be? Multiple, but we do not have multiple chariots. You might think the whole of the chariot is there. But again, if you try to look at a whole, there isn't any concrete whole. There isn't any concrete objective whole. Take apart the part, there isn't no whole. So whole and part, they mutually depend on one another. So these are two kinds of reasoning. And then without an independent part, you cannot have an independent chariot. So independent chariot and independent parts of the chariot, they do not depend on one another. There is no independent chariot or parts of the chariot depending on an independent chariot, or neither, nor do we have an independent chariot depending on its independent parts. So four, and then we cannot say think of an independent or concrete whole of a chariot, or to which part of the chariot to which the chariot belongs. So five, and then neither the color or the shape of the chariot are the chariot. So sevenfold. So although it does not exist in these sevenfold possibilities, both on the level of suchness as well as worldly conversion. So when you do investigation, there are two modes in investigation. One mode of investigation is where you do not take into the ultimate nature of the things. Where if I try to see who is this person, this is Geshe Thamjola, and there is Professor Sisirai. So here, to determine that this is Geshe Thamjola and there is Professor Sisirai, I don't have to go into the ultimate nature of these two people. So there is some kind of analysis there. So that kind of analysis is not considered when we establish emptiness. Now, different kind of analysis. Okay, there is Professor Sisirai here. All right, okay. Everybody agrees that there is a professor called Sisirai here. But where exactly within Professor Sisirai or within me, self, how do I find myself? So, if there is no conflict with your own perception of I, if it doesn't conflict with reality, we don't have to address emptiness. But if it conflicts, then we have to remedy that conflict. So that's the purpose of establishing emptiness. Now, since there are three kinds of dependent origination, because things are relative, they don't exist independently. So, depending on parts, you have whole. Depending on causes and condition, then you have result. Depending on imputation. So, for example, when I graduated, 1 second before my graduation, I wasn't called a Geshe. 1 second later, I got to be called a Geshe, but the same person. So, the fact that I had to go through these ceremonies, depending on that, I got a Geshe degree. So now that people call me, that is actually based on imputation. Nothing physical has really changed. And now the fact that even though my hands are not me, for example, on my stomach, I'm having some problems today because of what I wrongly ate yesterday, copying from my friend here. So even though my stomach is not me, but when my stomach is having some problem, it's not healthy or ill, I would say I'm ill, right? Even though my hand is not me, or my lips, tongues, throats are not me, when they work in combination, I say I'm speaking. So dependent on the parts. And causes and condition, now you go to the conception of me in my mother's womb. Trace the physical origination. Before my parents decided to have me, there wasn't a person called me confined to this life. So in terms of depending on continuity, we can say I existed in my past life, and continuity of the mind stream, I would say I would go into next life, but not this physically concrete person. I'll have to collapse, I'll have to die to go to next life. So if you think in terms of how we come to be produced from causes and conditions, how we depend for our existence on parts, how whole depends on the parts, how parts depend on the whole. For example, this is my hand, Sonam's hand. If there is no person called Sonam, you cannot call this a Sonam's hand. But without this hand, you can also have a person called hands or parts. You cannot have a whole. So whole part depend on one another. Cause and effect depend on one another. You cannot call something a cause without a result. And again, you cannot call something a result without a cause. Result and cause depending on one another. So this mode of dependence ultimately infers that nothing exists from the side of the object. And so, since they do not exist from the side of the object, the mode by which they exist is through mere dependency, or through mere mental imputation. So, by being mentally imputed, we are not saying that only the imputation exists and not object. Neither we are saying that only names exist and not object. Merely imputed means not existing from the side of the object. Okay. Yeah, I'm getting there. So, I'm going to wind up now. When you have a proper understanding of emptiness, as if I may say so, I just remember this incident in Delhi when I visited with one of my cousin sisters, AIMS Institute of Psychiatry. I think the doctor's name, if I remember it correctly, Professor Chawla, said, you monks, you just do prayer, you eat, and you sleep, you don't have any job. And at that time, I didn't have the courage to explain anything about these things. So I just said, yes, we just eat, sleep, pray, that's all. But that's not it. We study philosophy to practice through meditation. So if you have properly understood emptiness and if you properly meditate on emptiness, then this is the kind of experience you would have, as Tsongkhapa relates in his quintessence of excellent instructions, or what is also translated as essence of eloquent speech by other translators. In Tibetan it's called Lekshen Yimbo. At the end of the text, you'll see this. The crucial points of profundity and vastness, so difficult to fathom, even for those bodhisattvas well learned in all the academic fields, having found them perfectly and upon properly developing familiarity with them, as my mind is completely satisfied with the great celebration that arose from the impeccable single-pointedness, wisdom, discipline, sometimes pure faith in the Buddhas heighten upon me. On other times, I remember the kindness of the great pioneers of the tradition. And on other occasions, respect for the learned masters, as well as compassion for the destitute sentient beings, as well as the wish that this precious doctrine of the Buddha continues for long. All of these continue to proliferate as if competing with one another inside me. Therefore, the difficult points that have been long lost, having discovered them, that means the intricacies about emptiness, having discovered them through modes of reasoning as shown by Nagarjuna, Chandrakiri, etc., saying how marvelous their magical display is, even when I'm alone, on my own, I could not control words of absolute joy that just slipped through my tongue. With this, I stop here. Thank you.
Thank you very much. Very nice. And essentially what he said was that knowledge is not realization, and realization is not liberation. So you have to go to the liberation ultimately. And I now invite our next speaker, Dr. Professor Abhishek Majhi. Abhishek Majhi is I will cut short the CV, PhD, MSc, post-MSc and PhD from Saha Institute of Nuclear Physics, Kolkata, and he did his postdoc from Met Science, Chennai on quantum gravity, and right now he is an Inspire Fellow at Indian Statistical Institute, Kolkata, Inspire faculty, where he aims to describe radiation from non-singular black holes, where his main obstacle was understanding the distinction between the words classical and quantum. That's not surprising. Niels Bohr and Einstein fought over that for a long time. So this led him to realize the emptiness of the language of physics. So he has already arrived at the emptiness. From 2019 onwards, he has been on a journey of self-inquiry concerning his own expression, experience, language, and silence. Currently, he works on the foundations and philosophy of mathematical science, which involves a study of the literature of the West and the East, irrespective of any category, logic, mathematics, physics, philosophy, etc. So, Dr. Abhishek Majhi will speak on Buddha beyond quantum, self-inquiry with the language of physics and the foundations of calculus. Doctor.
Hi, hello everybody. First of all, thank you for being here, and Professor Jain, thank you for your kind introduction. I'm very honored and happy to be here because I have never gone to such conferences before where people discuss philosophy. So I am a bit nervous, but also happy again. So, and also my thanks goes to the Tibet House Authority to let me speak here, and of course Professor C.C. Roy, who actually made that happen. Okay, so let me not waste more time because there are a lot of slides. The slides are heavy, so please don't try to read all the things. There are a lot of references, so I will highlight what is important and I'll speak for that. Okay, so Buddha beyond quantum, a self-inquiry concerning the language of physics and the foundations of calculus. So let me not waste time and it doesn't work. Okay. So here is the outline. The talk is going to be divided into this 5 parts. So at first I will discuss the motivation for this talk. This is Buddhism and quantum physics, and can we look beyond such association? So that is the motive. Then I will discuss some manifest Buddhist features of the language of physics, then the foundations of calculus and its direct link to the Heisenberg uncertainty principle within 3 or 4 steps, which is not generally what we practice in textbooks. And then I will discuss the non-singular structure of two-body interactions. That is, one is for Newtonian gravity, what we learn as Newton's law of gravity, and another is, if time permits, I will show the non-singular structure of the two-body interaction of two charges, okay, which we know as the Coulomb's law. And finally, I will conclude with a glimpse of what I call non-standard physics, and it will be a realization of why I am talking about this language again and again. So let me go forward. So here, what is the motivation for this talk? The motivation of Buddhism or Eastern philosophy in general is done with quantum mechanics and not physics in general. Okay, so if we look at the history, the inadequacy of classical or Boolean logic actually got connected to quantum mechanics through von Neumann's work, where quantum logic came in. And then of course there can be discussions found by Schrödinger, Finkelstein, Zillinger, Rovelli and many others. So all of them, if you see the discussions, somehow boil down to the relation to quantum mechanics and how we interpret quantum mechanics. So now, there is a bit of exception recently, of course by me, and that's why I am here to talk. So there are a few articles which I have wrote about, and it directly affects how we do physics. It's not about the philosophy itself, but there are some new results which we can write down, which I think is connected to Buddhist philosophy. But again, I will beg your apology because I am not from a philosophical background. But while I got into the texts and saw that what is written there and how they interpret, I found some connection. So that's why I am connecting Buddhism to this. Okay, so now one of the features which I noted, so as His Holiness the Dalai Lama wrote in the foreword of a recent book in 2014, that experience takes the precedence in the Buddhist way of making inquiry. A similar tone is also found in Einstein's writings, where he said that, okay, so physics is a logical system of thought whose use is justified by our sense experiences. So by sense experiences, he meant that whatever experiments we do in the laboratory. But the relation between these two is done through intuition or our intellect. Okay, so the logic is not the complete thing. And the connection between these two, that is our experience and our reasoning, is done through the language. And this has been discussed in the context of Indian philosophy in detail in the book that I have referred to here, where the power, the mathematical or structure or the grammatical structure of Sanskrit has also been emphasized in this book by Bimal Krishna Matilal. Anyways, but we are doing science in English here. So what can we do and how far can we go? Now there is another take to this. There is an implicit emergent connection of Eastern philosophy to language of physics recently through the hands of one person whom many of you know here. His name is Nicholas Gisin. Okay, he is a famous quantum physicist. So let me start from this. So physics as a logical system of thought, as Einstein claimed, is actually the manifestation of the essence of Hilbert's call for mathematical treatment of the axioms of physics. It is the 6th problem in his list of 23 mathematical problems which was famously penned by him. So what was the intent of Hilbert? Suppose we have heard a lot of debate today here, okay, regarding, so what is a particle, what is a wave, mass, intrinsic property, extrinsic property, whether it's an ultimate reality, and lot of stuffs. So Leibniz said, Leibniz, who actually discovered calculus, as we say, but it was actually discovered in India. Anyways, so that Gottfried Leibniz, the German, I think, he said that, okay, so if we can calculate reason, then we don't have to debate. Because if we calculate, then it's 1 + 1 = 2. So it's simple. But it is harder done than said. So then came Boole into the picture. Okay, he wrote Investigation of the Laws of Thought, and there he said that, okay, so if truth told twice is truth, lie told twice is lie, then x² = x is the formula in algebra from which we can get two roots, 0 and 1, with which we can present the true and false. So that's how the foundation of Boolean logic came in. But that was regarding mathematical logic, foundation of mathematical logic. What Hilbert tried was to put all the axioms of physics and how we speak, to put them into this propositional form and do the analysis. But then there was another person whose name was Jan Brouwer, and he actually, as I have heard, while giving lectures in mathematics, in between that he used to quote stanzas from Bhagavad Gita. Okay, so he told that, okay, so logic is always incomplete. The foundation is the intuition through which we set the logic and we use logic. Okay, and that guy actually got bankrupted towards the end of his career because he was fighting with David Hilbert. Of course, again, that is connected to quantum physics, as you can see, where he emphasized Brouwerian philosophy and emphasized the role of the language in physics. So now, what are the manifest Buddhist features of the language of physics? And when I say language of physics, I mean the elements of physics. Not quantum mechanics, not classical mechanics, but this is the way we do physics. So in 2019, so this is an example, in the 2019 convention of metrology, where the redefinition of units happened. Okay, so what they did was that they redefined the units, kilogram, meter, etc., in terms of the fundamental constants and some technical constants, which they said the defining constants. So the motivations were to make those definitions logical. Okay, so here the principles, that is reason and testimony, came before experience, according to their claim. But then again they wrote that, okay, so this is also done, one of the other motivations is to consider the laws of physics as the basis, the standard laws of the physics. So there again testimony before experience came, somehow. However, if you note, since we were talking about gravity as well, besides quantum mechanics, the gravitational constant is also a fundamental constant there. However, this is not in the list of the defining constant. So where is the logic behind that? I talked to Michael Stock, who is the current chairperson, I think, or director of the physical metrology department. He said that, Abhishek, in the email, there is something called operationalism, which is besides logic. If we can't measure G to the required precision, then we just throw it out. So it is the way physics is done, which is neither completely logical, which is neither completely operational, but through the middle, being logico-operational. Okay, so this is what I find akin to the middle way, the notion which we have. But anyways, that is a bit superficial. Now, let me be a bit more concrete. And so now go to the very elementary question. We use the word quantity, okay, length, time, etc. So the definition of quantity as given in the standard vocabulary of metrology, there the quantity is defined in terms of a reference, where a reference is again a standard quantity. Okay, so there you can see here. So definition of quantity, it is done in terms of a reference, where reference can be a measurement unit. But again, the measurement unit is actually a standard quantity in terms of which we measure. Fine. So then the logician will say that this is circular reasoning and fallacious in logic. But the physicist says the concept is, definition of a concept is synonymous to the corresponding set of operations. So again, it can't be completely decided whether logic is there or just the operation. It is somewhere in between. So now, here comes the thing. Oh, it's, was it 20 minutes, right? It's done. Okay, so then I have to stop here. A lot of things were there. Anyways, okay. Okay, so maybe I'll stop by here. After this, I'll go to the result somehow. So, if I go into logical definition of quantity, see that we start by considering this physical dimension, which is not number, but for doing dimensional analysis, we treat them as numbers. So again, here is that. So here, what I am going to fair and can't actually write a 0 here. Exact 0 is not possible. Then there is no verbal interpretation of that. The only thing which we can write is one quantity is very, very small compared to this. But this is important because now with this thing, okay, let me skip this. So let me go to this. So this is, so how does this affect the foundations of calculus? This is the definition of derivative by Cauchy, where he wrote the derivative of a function is given by this expression where this delta y by delta x, both of these quantities are infinitely small quantities. However, as I said you, that exact zero is not allowed. So, and also the comparison needs to be there. That is the relation between two quantities. So now let us see what happens. So the displacement of an object as a whole, which we write in classical mechanics. So delta x related to lambda naught, which is the unit, through a number which cannot be completely zero. And again same for the time. Now this is the relation between, or the translation between the computable form and this is the verbal language. Now if I take this relation from here, that is, take this relation from here and rewrite Cauchy's prescription, then you can see to define instantaneous velocity, what you need are these two conditions, delta x very, very less than lambda naught and delta t very, very less than t naught. Similarly, for the rate of change of momentum, we need to do that as well. That is delta p very, very less than p naught and delta t very, very less than t naught. From there, what you can immediately see, that if we say that the third condition, that is delta t very, very less than t naught, we just say that this holds, but if we look at the other two, it straightforwardly gives us this relation, that is delta x into delta p very, very less than L naught. Okay. And this is your definability conditions for the laws of motion. So, and if this is violated, then our classical mechanics is not valid anymore. Okay, so here I will stop because I don't have time, but anyways, thank you.
Thank you very much, Abhishek. I think you needed much more time, and maybe sometimes again we will have opportunity to listen to you. Our next speaker is Mr. Lotus Namgyal. Mr. Namgyal is currently a senior research fellow at Punjab University in the philosophy department, working in doing his PhD in the field of Buddhism and modern science. He has a very varied background. He is a bachelor's degree in engineering from University of Delhi. Then he has Masters of Arts in philosophy, and he has been studying Buddhist philosophy at Tibet House through its various programs. And he has also taught Indian philosophy at Delhi University's College as an assistant professor. Mr. Lotus Namgyal will speak about convergence and divergence between quantum theory and middle way philosophy in Buddhism. Please.
Thank you so much for the introduction. Good evening, respected guest of honors, venerable monks, and all the scholars. I'm extremely humbled to have this opportunity. To have this opportunity to talk in such an important conference, and of course, I want to thank Tibet House to organize such a brainstorming conference on quantum physics and Buddhism. Well, I think I have not much time left, so I'll try to wrap it up in a very quick manner. I personally believe that there's always a scope to relook into any discourse from the very roots, from the very foundations. Therefore, I'll start by stating the very obvious and simple things. With my limited capabilities, and I'll try to figure out how Nagarjuna would respond to a quantum physicist on the wave-particle duality. I believe many quantum physicists might also agree to a certain extent, though physics doesn't work like this, as Professor C.C. Roy was telling. It's more about experiments. Still, there are thought experiments also, so debate is always important. So if a subatomic particle is explained as a wave, why does it exhibit the particle nature? If a subatomic particle is not a wave, why does it obey the rules of a wave? If a subatomic particle is both a wave and a particle, then why can't it be demonstrated simultaneously? If a subatomic particle is independently existing subatomic particle is not grasped, that is explained as emptiness. Upon observation, but we find the subatomic particle, that is explained as dependent origination, which is the middle way the Tathagata has taught. In the history of science, subatomic particles like electron, photons were first understood and projected as particle. With later experiments, it was found to be a wave as well. We understand what a particle is as we can easily visualize its characteristics, like it has a position in space, it has a position in time, it has a shape, etc. Wave, on the other hand, spreads out in space, as my fellow was, as he was explaining how wave spreads out in space, and we cannot pinpoint a specific location. For instance, a ripple. Well, my main point is that particle nature and wave nature are very distinct, are different fundamentally, mutually exclusive. We cannot imagine the ripple being turned into a pebble the moment we look into it. In case of a subatomic particle like an electron, figuratively we get to see such instances through wave collapse. Well, let's understand that a subatomic particle exhibits both wave nature and particle nature depending upon the nature of experiment. If the measurement instrument is fixed for a study of particle nature, we get to see the particle, or on the other hand, if the measurement instrument is set to study the wave nature, we get to see a wave, right? So keeping things as simple as possible, an analytic philosopher would question why a subatomic particle is called a particle in the first place. Because if everything depends on the nature of experiment, why is it called a particle in the first place? Also, the word subatomic implies that there is if we deconstruct this word subatomic, we see the reductionist approach employed in science. And maybe we have already decided what we are looking for. We are looking for still smaller particles. Looking for smaller particles is not a concern here, but looking for smaller particles with intrinsic property will be a concern for the Madhyamika philosophers. Well, reducing the nature of microscopic world to a wave or particle is not successful because the paradox of wave-particle duality has already entered the scientific arena. We cannot tag them as either wave or a particle. So here I'd like to bring out my main point, that problem lies in reification, in hypostatization, in reification of subatomic particles. Reification is seeing something abstract as concrete. From a Madhyamika point of view, it is seeing dependently originated things as inherently existent. The human tendency of reification has come to a temporary hold in case of wave-particle duality, but it has not been eliminated completely. Well, Niels Bohr came up with this beautiful principle of complementarity, whereby he explained that the wave theory and particle theory are not two different and exclusive natures of light. They are rather complementary forms. Both the theories together give us a full-fledged description of subatomic particles, like even a light or an electron or whatever. Both the theories, if considered together, only then we get a full-fledged explanation of the nature of subatomic particle. Complementarity connotes mutual exclusion but joint completion. For me, it's the start towards twofold truth, as Professor C.C. Roy was telling, that within science there is nothing like twofold truths, two truths. But for me, it looks like this wave-particle duality is the seed towards something like twofold truths, not in a holistic manner, but maybe it serves as a seed. On the other hand, while Nagarjuna talks about two truths, can we say that two truths of Nagarjuna are complementary in nature? Like, or if we talk these two in a comparative manner, are we limiting any of the concepts? I'm not talking about isomorphic resemblances. Of course, I'm not talking about it. I'm just trying to posit. I'm just trying to debate whether such a conversation between the two streams, two disciplines, is ever possible. For me, I think we can compare the two at least as an epistemological tool. We can compare the two at least as an epistemological tool regarding the entity in question. Regarding the entity in question, I'm again saying from the object's point of view, because the doctrine of twofold truth is a method employed to coherently explain the reality as something which is dependently arising but empty of inherent existence. From the point of view of object in question, both twofold truths and complementarity are the same, mutually exclusive but jointly complete. There is no hierarchy in the nature of reality from the object's point of view. We cannot say that the particle nature is of higher reality or wave nature is of higher reality, or from object's point of view, if we cannot say that conventional reality is higher, is at a higher reality, is at a higher level than the ultimate reality. Having said this, I also want to point out that it does not make sense to talk about the nature of reality from the object side, from the object's point of view, unless and until an observation is not done, unless and until an experiment is not done. We cannot say about its nature before the experiment, whether it's a particle nature, it is having particle nature, whether it's having wave nature, or in a superimposed state of both the states, or neither. In both complementarity and twofold truths, unless an observation is not made by the experimenter or a practitioner, talking about the nature of reality before that observation is somewhat futile. So we see there is a subjective touch, at least in the act of explanation, act of explaining the nature of reality. So is it the subject who somehow decides the nature of reality as a wave or as a particle or conventional or ultimate? This debate is very, very old in philosophy, even in Buddhism, and relatively new in quantum physics with the advent of, in physics with the advent of quantum physics only. In case of wave-particle duality, it is the nature of experiment, and in the case of two truths, it is the level of realization of the practitioner. Chandrakirti explains in his Madhyamika Avatara that the same water is seen as the humans by, seen as water by the humans, and pus by the pretas of lower realms. So here I'd like to quote R. Nagarjuna on samsara and nirvana. Samsara does not differ even slightly from nirvana. Nirvana does not differ even slightly from samsara. The ultimate nature of nirvana is the ultimate nature of samsara. And between the two, slightest difference, even the most subtle, is not found. So the same light is considered as wave, the same light is particle, the same place is samsara, the same place is nirvana. The nature of experiment decides for its particle nature or wave nature. And for the Buddha, the same place is nirvana, for the same place that same place is samsara for us. There is always a subjective touch in explaining the reality. Therefore, as epistemological tools, complementarity and twofold truths can be studied in a comparative manner. But ontologically, a Madhyamika would argue that everything is empty of inherent nature, the wave nature, particle nature, conventional nature, even the ultimate nature, when they talk about emptiness of emptiness. For a Madhyamika, both complementarity principle and twofold truths are epistemological methods and therefore mere conventional. The qualities like spin, the qualities like charge, etc., ascribed to subatomic particles are a form of reification. A Prasangika Madhyamika would ultimately reject the intrinsic nature like spin, charge, etc., but not from a conventional point of view. If I have time, do I have some time? Okay. I'll also talk about measurement problem in a very crude manner, in a very shortcut method. To build a context, it is all about an object, a subject, the act of cognition of the object by the subject, through sensing the measurement instruments. In a crude sense, it revolves around, measurement problem revolves around here. Before the act of observation, a subatomic particle is in a state of superposition. Before measurement, quantum system is mathematically expressed by Schrödinger wave equation as a probability wave, but physically we don't precisely know how to represent it. We can only talk in terms of probability. And this has challenged the old classical determinism. Before measurement, the quantum system is believed to evolve in a complex Hilbert space that has infinite dimension. The problem is then how to reconcile the vastness of Hilbert space of possible states with the observation of comparatively very few macroscopic states such as position and momentum. It is said that the act of observation causes the wave function to collapse, and the result we get is actual and not probable. The problem can be, this measurement problem can again be attributed to the age-old understanding of causation. The problem, we are trying to forcibly adjust this measurement problem into a mode of science that has been developed hundreds of years ago, which is more or less the classical physics, right? The problem can also be seen from the issue of reification of causation. How do we see the causation, the idea of causation? That has been reified. From a Madhyamika point of view, this measurement problem can also be seen from the issue of reification. Well, such a view is not easy to break. Of course, it's not easy to break because of historical continuity of the view where relata precedes relation. Again, Professor C.C. Roy was talking about superposition principles and stuff like that. So I'd like to again question that if the wave collapse has not happened, the quantum system is supposed to is considered as one system. So you cannot talk about its independent natures as relatas. So relations do not exist before the wave collapse, or does it? Maybe we'll discuss it later. So relations exist but not intrinsically, which is why scientists apply them practically. Nagarjuna never pointed towards relata preceding relation and explains that relation is what makes the relata emerge. Well, in this chapter, Nagarjuna again talks about that subject only emerges when there is an object of awareness, and that object with no subject is contradictory. From Madhyamika school's point of view, I think it is correct for me to even question, is measurement problem a real problem? Is it a problem in real sense? Quantum particle, measurement tool, classical theories, act of measurement are all dependently arising. So an independently arising quantum particle is ruled out under the light of Nagarjuna. Interestingly, following the Chatushkot logic and argument of Nagarjuna, non-existence of quantum particle is also not an option. Hence, the reading we see on measurement apparatus is also not ruled out. It can be placed within the conventional truth of Nagarjuna's twofold doctrine. Quantum physicists are looking for an explainable relation between observer, measurement tools, quantum particles, and so forth. The Arya Nagarjuna would argue that relation, if found, will also be dependently arising and empty of an independent existence, which means that relations do not exist in an intrinsic manner. Well, I think I should conclude. I'm simply arguing today that from Madhyamika point of view, various issues concerning quantum physics has its basis in reification, has its basis in hypostatization. The way we look into reality from a reificationist point of view, that everything we see, we see the abstract things as concrete, we see dependently originated things as intrinsically real. That's where the problem lies. That's what I'm arguing today. His Holiness the Dalai Lama has been emphasizing this, the need to create dialogues, and Tibet House has always been very active in organizing such debates, and I'm very thankful. The fact that His Holiness refers to the scientific community as the fourth jewel after Buddha, Dharma, and the Sangha is in itself a proof that Buddhist theories are subject to scientific outcomes. His Holiness has categorically expressed that anything science proves wrong, the Buddhist perspective the Buddhists will accept it as wrong. Right? This is indeed not a challenge. Rather, it is all about mutual growth for both the scientific community and the Buddhist community. I'll conclude with this picture where you can see His Holiness the Dalai Lama discussing with recent Nobel laureate Anton Zeilinger. And as a student of Arya Nagarjuna, I'm not positing anything from this picture. Also, I'm not saying nothing. Thank you very much.
Thank you very much for your nice conclusion. I think all the talks are over. And do you want any question answer session, or it's too late for that? I think we can skip that. Okay? Thank you very much. we'll close the session.
Thank you very much, Professor Ashok Jain ji, and our speakers for this wonderful session. I wish we could give more time for question and answer sessions, but due to time constraint, we have to skip that. Okay, so now I request our secretary, Mr. Chotinla, to kindly come up on the dais and present souvenirs and khata to our speakers and chairperson. Our chairperson, Professor Ashok ji. Kishing Aung Sanam La. Professor Atul Kumar ji. Okay, Professor Abhishek Maji. Mr. Lotus Namgyal. And Professor Atul Kumar. Thank you, Chajotinla. Okay, to conclude this event, I would like to take this opportunity to, on behalf of Tibet House, to thank all the speakers for accepting our invitation and presenting your, for participating in this conference and for sharing your profound knowledge with us. I would like to thank our wonderful audience and students for participating and being with us till the end. I extend my heartfelt gratitude to Venerable Geshe Dorje Damdullah, Director of Tibet House, who although couldn't join us, but whose guidance have been with us and has greatly enhanced our capabilities. Last but not the least, I would like to thank my colleagues for all the efforts and enthusiasm towards putting all this together. Thank you. We hope to see you all again soon in our various events and seminars. As you can find in our program kit, we are organizing the conference on neuroscience on 24th December, and we are opening the registration for the 4th batch of Nalanda Diploma course on 9th of December 2022. Thank you. I would like to request our speakers to kindly join us on the dais for a quick group picture. Thank you.